DePIN or decentralized physical infrastructure networks. That's a jargon we're going to learn about today by building a project on top of it. We'll understand what is DePIN, what companies have found PMF in it, how do you build a DePIN platform yourself, and some Web3 constructs to build something like this. A quick call out, we're doing the Solana DePIN Summit on 24th of March in Bangalore. You'll meet a bunch of founders from these companies over there. I'll be there myself. I have a speaker talk as well as a workshop. So if you want to learn from me live and meet a bunch of founders, hopefully network and convert into a full-time or an internship opportunity, conferences are an underrated way to do this. So if you are in Bangalore, link is in the description. I'll see you on 24th of March. For everyone else, let's get into the video. All right, let me set the context. This is what we're building. You might have heard of Better Uptime, which is a uptime monitoring platform. What does it mean to be an uptime monitoring platform? Okay, whenever you have a website, for example, I have 100xdevs.com. This website might go down from time to time. Its API endpoint might go down from time to time. And a uptime monitoring platform like this monitors this. If the website goes down, it sends me a message. If I don't respond to a message, it calls me. I can pick up the call and quickly fix the issue. These platforms are used to usually send out notifications to developers of a team or the CTO of the company whenever your website is down for whatever reason. How do you add an alert? Just go to the website, sign up, click on create monitor. Whenever the URL becomes unavailable, I want the alert to kick in. The URL to monitor right now is 100xdevs.com. And I want email, call, SMS, push notifications, so on and so forth. And I can create the monitor. Whenever this website goes down now, I will receive an email. If I would have checked call, then I would have received a call, so on and so forth. So there are a few components to build over here. But this is the Web 2 version of it. Let's see this in action really quickly, and then we'll understand what does it mean to add DePIN on top of it? Where does crypto come into the picture? How does decentralized physical infrastructure networks make this a viable use case to build? Let's get into that next. All right, it's been a while now, and I can see graphs around the uptime of my platform. As you can see, it's currently been up for 3 minutes. It was last checked 2 minutes ago, and I can clearly see that from the North America region, my website is accessible at a 90 millisecond latency in the first lookup over here. Then there was another lookup that happened at 3:57 p.m. There the latency was a little bit higher, 35.2 milliseconds, so on and so forth. But my website is up. It is not down at the moment. If I do crash 100x devs right now, which I won't, then you will see an alert being pop up. You'll see this green becomes red and I will receive an email. That's what this website is supposed to do. And notice the challenging bit here is there's not one region that's monitoring it. There are many. This is where physical infrastructure networks come into the picture. Right now, what is happening is when I come to the website, if this is the world map, let me try to create a janky one. If I have hosted 100x devs right now, let's say in India on a server over here, there are multiple servers, one in North America, one let's say in Australia, one of them in Africa, and one in South America, maybe, or Canada. That's constantly after every 3 minutes hitting my server and checking, is the server up? Do I get back a status code of 200? It's also monitoring how much time does it take for this request to respond back. This is great. This is actually enough to measure the uptime of your platform because 4 regions are good enough. But what's the downside? The downside is you don't actually know if there is a village somewhere in India where it is, or somewhere in the US where it is accessible. You have not really captured every little corner of the country. You probably have, or Better Uptime probably has a data center over here in AWS through which it is trying to monitor my system. DePIN or decentralized physical infrastructure networks would ensure that anyone around the world, I repeat, any person, any small validator, any person who wants to earn some crypto off this network can start monitoring this platform. In the end, I exist / live in a society over here. And if it works for me, then it hopefully most probably works for everyone in my society. If you have a bunch of these physical infrastructure networks, if you have a bunch of physical infrastructure all around the world, which is nothing but people in a society, in a school, in an office, that have their machines constantly running and constantly pinging this platform, you can measure the real health of your platform. You can measure, is this platform accessible from 100 different locations all around the world, the deepest of the network, somewhere in the trenches of Africa? Are those people able to access my website? You can't do that as a centralized company. You can't, as a centralized company, you can host your servers in 4 different data centers that are constantly pinging the website. You can't really own the complete infrastructure. You can't own the web. This is where physical infrastructure network helps. You, a random person who has a machine, I have my machine, I have 3 Macs over here. They're not doing anything. They're not earning me any crypto or money. But I do have compute. I do have network accessibility. I can access the internet right now from a few idle machines at my house. Wouldn't it be nice if I can leave my idle machines on? They can constantly ping a bunch of websites that that are users to better uptime, 100xsteps.com, google.com, facebook.com. They can constantly ping it and monitor their health and let better uptime know if the website is up or not. That way, the end user, which in this case is me for monitoring 100xsteps.com, I get more visibility into the uptime of my platform. These people, call them validators, call them verifiers, they get some crypto in the process of verifying it. If they keep doing this for 30 days for a platform, the platform would be willing to distribute, let's say, a fee of $50 amongst all of these validators that have helped secure the network, or in this case measure the uptime of the network. So it's a very good PMF for the company as well, for people who have idle compute and network as well. This is where Deepin comes into the picture. The most famous company of Deepin, if you've heard of it, is the Helios network. And what they're doing is, Helios is building a decentralized Wi-Fi sort of a platform. Basically, right now you have to pay whatever Airtel or Geo, and they have centralized wires, which means they own all their infra. If you've ever tried leasing your terrace to Airtel, they'll probably take it from you and put a tower over there. They own the tower, they own all the networking, the wires, or they rent it. But not like we don't ever get value. I have a house. My house ke top pe I can put a tower, but I don't really get a value other than rent. That too only a few people do. What Helios is doing is it's giving everyone a device that you can put in your house, and that way slowly try to create a full Wi-Fi network. If everyone in my society puts a small router that's eventually propagates to more routers, everyone around me in other societies, we can all be connected via a different layer on the internet. We are all providing networking capabilities, Wi-Fi to the platform, and hence we all should be incentivized. We'll all be paid with the Helios token. That's where Deepin comes into the picture. Another one is, if you've heard of another company called Huddle, which is doing a decentralized WebRTC platform, which means what happens in case of WebRTC is you again need a bunch of machines all around the world to transfer video. Like transferring video is very expensive. But if a lot of these small validators or miners are become open to transferring video from point A to point B, then these small validators can be paid a fees for transferring that, and you don't have to give that to AWS. So these are two examples of Deepin platforms. What we are building today is better uptime, but in a decentralized fashion, a decentralized version of better uptime, where a user will come, register their website, and all the validators that are currently running will keep checking the website, keep pinging the website, and keep reporting its health. If some of the validators say it's down, then you can let the user know, okay, 30% of our traffic feels, or 30% of our validators feel you're down, 70% of our validators feel you are right. And then I, as the owner of 100x Devs, can figure out, acha, where is this 30% reporting ke things are down? Acha, it's in Africa, so probably there's some issue in accessing this website from Africa, and I can debug from there. So that is what we're building today. There are a bunch of challenges here. Crypto withdrawals, people would want to get paid. Making sure these miners are being honest. What if, the website is up, but a random miner is like, I want reporting that the status is down. You need to make sure that doesn't happen. So how do you incentivize or disincentivize behavior based on this? How do you make sure people are not reporting wrong things? How can you make sure they can get paid fairly? How can you make sure they're not able to double withdraw from your platform? It's secure in a way they're not able to get themselves paid more than what they've worked. Things like these are the interesting / difficult challenges here. Other than that, it's a simple full stack platform that will eventually look something like this, where people can come and create a bunch of monitors. Abhi I've created a single monitor, but if I want, I can create one for api.100xfs.com or video.100xfs.com, so on and so forth. In the next section, let's go through the architecture. What all components are needed for building like something like this simple Web2 stuff. After that, we'll understand cryptography and what all crypto constructs you need to make sure you're being fair and you can verify that every validator is performing honestly. Let's get into the architecture next. All right, let's break down the architecture into 4 parts. We have the core backend API. This is what our end users will be hitting when they're on a front end like this. So if I click on create monitor and try to create a fresh monitor to api.100xfs.com, I'll be hitting this primary backend or API server whose job is to make sure that this entry persists in the database. If I'm eventually querying, okay, what does the graph look like? What are the uptime over the past few minutes? That will also come from this core API layer. It'll hit the database, return me the entries. The second part is the hub. Think of this like the central orchestration layer. This hub is what all the validators would connect to, most probably through a WebSocket connection. And the validators would be told by the hub, okay, hey, please check this specific website. Please try to hit 100xdevs.com. Then this validator will hit 100xdevs.com and report back to the hub, okay, this might be the status code 200, 400. This was the latency. So every validator that comes up needs to connect to something like hub.platform.com through a WebSocket connection. And this will lead to information flow from the hub. The hub is that's the thing that's orchestrating. It's been 3 minutes. I need to now monitor 100xdevs.com. It will figure out, okay, I need one validator here, one validator here, and one validator here. It'll let them know, okay, please tell me the uptime of 100xdevs.com. They'll hit 100xdevs.com, get back the response time and return it to the hub. The third thing is the final worker node. This is the code that every validator that we have is going to run locally. As obvious, this guy will just connect to the hub. The hub will keep letting it know, please hit the specific website. It'll do what it's supposed to do and return back the response to the hub. In the middle of all of this, there'll be a bunch of cryptography. For example, if you're hitting a server and you're getting back a response, we somehow need to make sure, okay, this guy is being honest. He's not hitting the server. He's not trying to save network bandwidth. He's not being dishonest. He's responding back correctly and letting me know the correct status code, be it 200 or something else. So we need to somehow figure out a way to make sure people are being honest. We'll come to that section when we do, and we'll understand a little bit about cryptography, public-private keys, and how can we make sure that whenever this person is hosted on let's say 100xdevs.com, if they're indeed up, this platform doesn't lie about it. This validator doesn't lie about it, and it's able to respond back correctly. It's being honest. Eventually, as time goes by, our validators, let's say this specific validator, did 1,000 requests. So we need to incentivize them. So this validator, when they register, they will give us a Solana public key. And after they've done with, let's say, 1,000 transactions, we'll pay them something. Let's say, whatever, 0.01, either USDC, or we'll give them some SOL, or we can create our own native token and incentivize them. But in the end, these validators are only securing our network or helping us figure things out because they expect to be incentivized in the end. So ideally, there will be a fourth component here, which is nothing but the Solana blockchain, where whenever the person wants to withdraw, whatever their payout is, could be 0.1 USDC, they'll be hitting a transaction on the Solana blockchain and getting incentivized, getting the final payout. So this will be the high level architecture. Two difficult things that we'll reach eventually as we start to build it, because the version 1 is fairly simple, where this guy can be dishonest. Let's build that first. Fairly simple, honestly, just a Web2 challenge. No, not a lot of cryptography, not a lot of Solana payments there. After we have done that, then we'll understand a bit about public-private key pairs, hashing algorithms. And once we're done with that, we'll understand about Solana payouts and how can you actually make sure the person can get paid what they want in a decentralized fashion, avoid double paying, which is a standard challenge during withdrawals. And that's going to be the last section of the video. there are a bunch of challenges there. If you've done crypto withdrawals, they're actually easy. Crypto deposits are the harder bit. Unfortunately, we don't need crypto deposits here. But these are two very big challenges that we cover in the cohort as well. It's like a proper section on crypto withdrawals and deposits. So today we learn about crypto withdrawals, which is slightly easier compared to crypto deposits, which I'm happy to discuss the architecture towards the end. Okay, let's get into the coding bit. Let's start by coding the API first. Once we're done with this, then we'll move on to the next section. All right, before we start coding the application logic, let's create a fresh monorepo in which we're going to have 4 applications: Frontend, API, Hub, and Validator. We'll also add a package called database, which will help us connect to our PostgreSDB. Let's initialize an empty turbo repo by running npx create turbo @latest. I'm going to call this, let's call it dpin uptime. Let's select bun as our bundler runtime package manager. Let's open this project in Cursor. I'm disabling Cursor for now. I'll re-enable it whenever we reach the front end. We need 4 applications. We already have 2 default ones that Monorepos or Turbo Repo provides us. I'm going to get rid of one of them called docs. The one that we're left with is web, which is going to be our front end eventually. Let me open the terminal. Let me go to apps and let me introduce 3 more applications. The first one is going to be called API. The second one is going to be called Validator, and the third one is going to be called Hub. Let me initialize a empty bun project in all 3 of these. So bun init over here, bun init over here, and bun init over here. Now I have 3 end user applications for the backend and 1 for the front end. Let's start by adding the database as well. We're done with 1, 2, 3, and 4. Database we're not yet done with. So let's add a package, not an app, a package where we're going to initialize our database schema and initialize Prisma, which is the ORM that we're using today. So I'm going to create a fresh package called db. I am going to go into packages/db, run bun init to initialize an empty bun project. I am going to add Prisma over here. So bun add Prisma. Then I'm going to initialize Prisma, bunx Prisma init. That will initialize an empty schema.prisma for me, which will eventually put our models in, our tables in, our database ka structure in. I am going to create a new file called source/index.ts, where I'm going to export my Prisma client. Before I export my Prisma client, I have to run bunx Prisma generate to generate the Prisma client. Hopefully this is Prisma jargon that you understand. If not, this is standard things you have to do if you're using Prisma as your ORM, as your connector to your database. So let me do a simple table here called user. A user which has an ID as the default field, and by default it's a random UUID. Now let me generate the Prisma client. What does generating the Prisma client mean? It just means creating a @prisma/client folder in your node modules that you can export from here. Now export const Prisma client equal to new Prisma client, where Prisma client comes from @prisma/client, which is something that we just created over here, as you can see. Once that is done, the last thing to export something from a monorepo is go to package.json of that specific package. This db package that we have created, we're exporting something from here. But one more thing you have to do to actually export it is go to package.json and add a exports section where you write I want to export, let's say /client as /source/index.ts. So anything inside this index.ts file, everything inside this index.ts file, which in our case is just a single export for now, will be available to the other applications, these applications eventually uh, at the DB import. So eventually you can do this, import Prisma client from DB in various packages of ours. These packages can just import the database from here. That way, I don't have to reinitialize the schema in 4 different places or 3 different places in case the front end doesn't hit the database. All 3 of these, or actually just 2 of them will use the database, can just import the DB module. The we don't have to rewrite the schema in 2 different places, which begs the question, what does the schema look like? What should the database look like for an application like this, which is usually the first thing you should design when you're building anything. So in the next section, now that we've initialized 4 different apps, the API backend, the hub backend, the validator backend, and the frontend, and a package, the DB package, let's start the writing the schema of our application. What should the database look like, and then proceed from there. All right, let's design the schema of the application really quickly. We will have a users table, which will be our end users. This will have an ID, which will be a string, username or email string, maybe password, but we'll probably use Clerk, so you will not need password. Authentication will be handled by Clerk. Is that it? Is that all you need for the users table? Probably. We'll see if we need more things eventually. Then we will have another table called websites to track our websites. Either is fine. We'll have ID, which is a string, URL, which is a string, and there will be a foreign key relationship here. So user ID, which will be a string. There will be a one-to-many relationship here. One user can have multiple websites. Then there will be a validator table. Any new validator that we get that wants to earn some money, validator will have an ID. We'll have a public key where we'll eventually pay them. This is their Solana public key or Solana address. What else? Maybe their IP/location would be good, so we can see where they're tracking from, where they're hitting our servers. Anything else? I feel like I'm cutting this short. I think we'll need more things, but we'll see. I think that's good enough for the validator. And then lastly, we need, let's call it website ticks. A tick basically means, if you've seen charting graphs or trading graphs, a tick is a single wick there. So if you go here to any 𝗁𝗲 like website, and if you're trading, let's say BTC, oh, it's futures. Where is spot? If you're trading BTC, each one of these lines that you see, this is called a tick, and we'll need something similar, right? Eventually, we'll need to create a page like this where users can come and see the status of their website. So the first website, second website, and we'll need like time series data like this. Okay, here on this tick at 9th March on 12 p.m. everything was green, or 70% was green, 30% was red, and here and here and here and so on and so forth. So each one of these, in fact, this might have 10 different entries. Okay, from the Europe validator you got a green, but from the Delhi validator you got a red. Each one of these rows I'm calling a tick right now. So what does the website ticks table contain? An ID, a website ID, which is a foreign key from here to here, a validator ID, which is a foreign key from here to here, a timestamp, which is of type date, and the status, which could either be good or bad, which means the website is up or the website is down. And finally, latency, which is a number. How long did it take for the validator to hit the website? In case the status is good, if the status is bad, it doesn't matter. All right. Eventually, these ticks will help us create a graph like this on the front end, where the user can track, okay, during this time window of 5 minutes, 30% of the validators said the website was down, 70% of the validators said the website was up. So, you can color this red at the bottom 30% and green at the top 70%, something like that. Is that enough? That seems like too simple of a schema. Thinking, but I don't. If there is more, we'll add it eventually. I think this schema is good enough, at least for the V1. So let's start coding the schema and then go from there. So let me open cursor. This was our original schema. What did we change? We'll add email as a field over here. Let's use Clerk for authentication, which would mean we don't need a password over here. Clerk will handle authentication for us. Anything else? Yeah, we don't need the password, so that's good enough. Then the model is called websites, which again, ID, string at ID at default UUID, URL string, user ID string, which is a foreign key. Now, ideally, you need to add a foreign key relationship here. I am not adding that because we are using Clerk for authentication. Clerk is an external service. So our user data will be stored there. We can sync our user data here. We can fill our users table over here along with Clerk. But the problem is that syncing might take some time, sometimes 1 minute, sometimes 2 days, based on how quickly we're syncing it. So I won't be able to put any entry here if I enforce the foreign key relationship. If I add code that looks like this, I can add this code. This will just tell Prisma that this is a one-to-many relationship. A single user can have multiple websites that they want to track. A single website has a single user that it's related to. It's admin user, it's creator user. So you can add this foreign key relationship. If you do add it, you just have to make sure the user table is always filled before you make an entry over here, which we can't really enforce. If we're using authentication as a service, if we're depending on Clerk, we can sort of enforce it if we just hope, okay, as soon as a user registers with Clerk, they immediately tell this to us through a webhook. But I'm not making that assumption, and hence I'm not enforcing this foreign key relationship. This one right here, I'm not enforcing. But this foreign key relationship and this foreign key relationship, I will enforce. All right. That's the websites table. Then validator. Public key. Let's do location. Would be nice for me to see, Delhi, say the one validator is there and so on and so forth. So we can do location. We can also do the IP. Let's store the IP of the validator as well. And then lastly, the website ticks table. Where we have the website ID, which is a string, validator ID, which is a string. All of these are foreign keys, so we'll add relationships very soon. Timestamp or created at would work. Date time, status. So it can be good or bad. So let me add an enum. Enum website status, good, bad. And latency, so that's how long it took for it to hit the backend, how long it took the validator to hit the backend on this tick. A single tick is a single validator entry that they're sending a request to the website. Now let's enforce foreign key relationships here. We have one foreign key relationship and two foreign key relationships. So the website will have the website will have multiple ticks, correct? So website tick or ticks is going to be website tick array, and a validator will have multiple ticks as well. So ticks website tick, and we'll have two references here. So one for website and at relation fields website ID references ID, and another one for the validator fields validator ID references ID. So we have enforced this foreign key relationship and this foreign key relationship. Now we can always be sure if there is a tick, there is a valid validator, there is a valid website for which this tick exists. Never can I have a random validator ID here that doesn't actually exist in my table. All right, cool. Feel like this is enough. To recap, this is what the schema looks like. Of course, I could be wrong, and we might be missing something. We might have to add a few more fields here, but I think for now this is good enough. So with that, I think we can proceed to the API now. Let's quickly start to write the routes that we're supposed to implement on the primary API. This one right here, and then maybe let's just implement them. There's nothing too hard to do here. The hub is where the harder bit begins. Very simple thing to add over here. Let's expose the endpoints that we can think of right now. And then when we reach the front end, then we'll see if we've missed something and if we have to add more things here. So let's move to the API next. All right, let's open API/index.ts. Let's go to apps/API and let's do a one add express and add types/express. Let's add the two dependencies. Let's start to use express and create a simple HTTP server. Import express from express, const app equal to express, app.listen, let's say on port 3000. Hopefully this is digestible. It's a simple HTTP server running on port 3000. Now we need to introduce the routes. What all routes will we have? The user will hit a create website endpoint, a get website status endpoint, a get all existing websites endpoint. I think there'll just be three. So we can just put them in the same file. We can structure it better if need be. But I think there's just three endpoints that we need to support. app.post/API/v1/website to create a website, app.get /API/v1/website/status. So this will return you the ticks of that website and whether or not the website is currently up. And then lastly, app.get/websites. This will return you all the websites that you currently have active. Maybe one for deleting. So app.delete /API/v1/website /:website ID. And yeah, that's good enough. Maybe let's have website ID be a query parameter here. Is there anything else that we need? No, I think that's good enough. So before we implement any one of these, hopefully it's clear, okay, all four of these need to be authenticated endpoints. Only if a user actually exists in our database, does it make sense for them to hit this endpoint. Only if the user has signed in does it make sense for them to be able to hit these endpoints. These endpoints shouldn't be hit by a user who's not currently logged in, which means we have to implement a middleware.ts. If you don't know what middlewares are, then this will be a little hard to digest. But long story short, if you have a bunch of authenticated endpoints, which in our case we do. You can do all the authentication logic here. Okay, get the users details from the headers. You can do that here. But you'll have to repeat that logic in 4 different places, which is why middlewares are good, because they handle all of this in the same place. They also end the request early if need be. If the user is not logged in, the request will end right here. It will not even reach over here. I think I need to import this as the type. Response and next, which will be the next function. Here we need to write all the authentication logic. Assume the user signs up or signs in with Clerk, and then they send us their auth token, their JWT that they got from Clerk in a auth header. So const auth header equal to rec.headers of authorization. And here we need to do a JWT.verify, some things that are related to Clerk. So I'm not doing them right now. After we reach the front end, after we go through the authentication bit on the front end, we'll understand what we export from the Clerk dashboard and import over here. For now, I'm just going to say rec.userid equal to 1, let's say, or since it's a string, or it also needs to be a UUID. So it just needs to be a string actually. So let's just do this. rec.userid is 1, and then let's call next. You'll see a type error, and of course, to repeat, this is wrong logic. This is hard coded. We're assuming every request is being sent by a user with ID 1. That is not true. 1 is a very weird ID anyways. We'll get a more complicated unique ID from Clerk eventually, but we will reach there when we reach the authentication section. Abhi, we're not in the auth section. We're just ignoring auth for now. But one common theme you'll still see after we introduce Clerk is you'll see this type error. Property user ID doesn't exist on type request. What it's saying is, okay, request doesn't have a user ID field, which indeed it doesn't. If you explore this type, you'll see it doesn't have a field called user ID. We're adding it explicitly, which whenever you do that, it means you have to add a new declaration file. What is a declaration file? It has a bunch of types. Whenever you want to export types, you export them in declaration files. What's a declaration file? A file which ends with .d.ts. And here we need to override the request object that you see over here. This request object needs to be overridden. We need to tell TypeScript, okay, express sure returns something, but we're going to add something on top of it, specifically a user ID field. So declare namespace express type request is going to have a user ID field, which will be an optional string, or interface request. Yeah. Adding this, what we're saying is, okay, in the express namespace, the request type or the request interface will now have something extra, specifically the user ID, because we're just, doing that here. We're updating the standard request object, which doesn't have a user ID. We're overriding it. We're adding one more field there called user ID. So TypeScript is happy. If you were writing JavaScript code, this wouldn't even be a problem. That's it for the auth middleware for now, and eventually we'll make it better. But abhi ke liye, since we haven't yet reached the authentication section, I'm just hard coding the value and adding this auth middleware everywhere. So in all 4 of these, we need to make sure the user is logged in. Only if they're logged in will the request reach here, and then we'll have access to a user ID value, rec.userid. And here we do the whatever standard insert something into a database. So what is it for a website? Await 𝗶𝗹𝗀. So here we need to put something in the database. Should I rewrite my schema here? No, schema already exists over here in packages/db. The schema exists, the database object exists. I just need to add it as a dependency here. So I can add db as a dependency, which basically means db star means okay, this database is going to be a dependency over here. And now if I do a global one install, maybe one more thing I should do before that. I have updated my schema, so I should regenerate the client. Prisma generate. I should also re-migrate my database, npx prisma migrate. I don't know if I should re-migrate or migrate for the first time. I forgot if I've already migrated my database. So, but npx prisma migrate dev will do what? It will say it's not working because if I open .env, I have a random Postgres database that I'm connecting to. I'm not running this locally. So if I do a docker ps, you will see I'm running Postgres locally. Let me stop it and let me restart. Docker run. This is the command that oopsie daisy. This is the command that you need to run Postgres locally using Docker. Docker run with this port mapping in detached mode, which means in the background with this environment variable Postgres image. This will start Postgres locally for you. There are other ways to start Postgres as well. This is just the easiest one. Run it using Docker. And now I have a database running locally. I can copy its password and paste it over here. The username for my Postgres database by default is Postgres. The database is also Postgres. This is the final credentials of my database. I can call 𝗠𝘁𝗶𝗹𝗀 prisma migrate dev now, and this will migrate my database. What does that mean? Basically means a migration.sql file is created. If you look at db/prisma/migration/init/migration.sql, there is a big file that is created which has a bunch of create table queries, create type website status as an enum, create table user, so on and so forth. It also adds foreign key constraints over here. If you look at it, alter table website track, add constraint. This is the name of the constraint, foreign key here, references here. So this SQL has been run against my table. If I look at if I quickly show you my docker exec dash, don't worry about what I'm doing here. I'm just trying to explore my tables. So if I do a select or if I do a /dt here, you will see I have a users table, validators table, websites table, and website tick table. All four of these tables were created because I ran npx or 𝗠𝘁𝗶𝗹𝗀 prisma migrate dev. What does it do? Migrates the database mein jata hai, runs all of these queries one after the other, and hence the validator table was created, hence the website tick table was created. 𝗠𝘁𝗶𝗹𝗀 prisma generate to regenerate the client. Hopefully you guys know what a prisma client is by now. And what does this command do? cd apps/API. So if you remember API/package.json, I added db as a dependency. What that does is, now in my API/index.ts, I can import prisma client from db. But of course I can't. See a red squiggly here. Prisma client is declared, but value is never used. So let me do that. Prisma client dot user dot create, still an error. Cannot find db or its corresponding declarations. So let's see what's up here. Package.json, did I add db as a dependency? I did. In packages/db, did I add in package.json exports section? I did. What is this called? This is called db. Everything should be fine. Let's rerun a global bun install. Now let's see if that fixed it. No, I still see a red squiggly here. I can already tell this will be really hard to debug, but let's try to debug it. It says cannot find db, but if I go to API, do I have a node modules folder here? I don't. If I go to the global node modules folder, do I have a db package here? ABC. I do have a db package here, which is a sort of a shortcut to the packages/db folder. That should be good enough. Maybe I just need to restart TypeScript server. Nope, that doesn't cover it. If I do a bun index.ts, oh, I know what it is. Maybe you guys were smart enough to figure this out before me, but I need to do a db/client. If you remember, in db/package.json, I added /client as the export, and hence when I'm importing here, I need to import it as /client. If I wrote client 2 here, then that is what I have to import over here. I added client as the export. I need to import here as the client as well. Prisma.user.create data. Sorry, not user, website. So user ID is what the backend gave us. I can add an exclamation here. What does exclamation do? If something can be string or undefined, see, in this case, it will not be undefined. If the control reached here, means the auth middleware indeed made sure that user ID exists. And hence, you can be sure that user ID will exist here, but TypeScript doesn't know that. TypeScript thinks this can be string or undefined because that's what we put in this d.ts file. We said user ID is optional. So over here, TypeScript thinks that user ID can be string or undefined, and it's telling you that you can't put string or undefined. This needs to be defined. Type. What is it saying? Type string or undefined is not assignable to type string. So because of that reason, in TypeScript, if you are sure something will exist, just add exclamation. That just tells TypeScript, okay, this will not be undefined. And as you can see now, the type is a strict string. User ID, URL. So we do expect the user to give us the URL. Const URL equal to rec.body. If you ever use rec.body, what does that mean? You have to add a middleware, specifically the express.json middleware. URL is something the user will give us, the URL they want to track. And is that it? Yeah, I don't see any red squigglies. That probably means the website table just needs the URL and the user ID. Ticks will come eventually. Let's make this async and let's return to the user the ID of the newly created website. So const data equal to this thing, and this will be data.id. Perfect. That's the first endpoint. Hopefully simple enough. Go through the auth middleware, get the user ID and URL, dump it in the database, return the user this. Now, eventually we need to start tracking this website. That's a whole different thing. We'll reach there when we reach there. It's just CRUD we're implementing right now, which is as simple as this. Give me the status of a website. So this needs to return all the ticks for that website. Hopefully in a smaller window, like a 30-minute window or a 1-hour window, we don't have to return all the ticks since eternity. Bigly we can do that, but eventually, the user should be able to filter, or generally just they want to see the last 1 hour of data. So the last 1 hour of ticks is what we should return here. One more thing this reminds me is yeah, that's fine, I guess. What I was thinking was, okay, maybe every website should have a status field which is up or down. We can probably do that. So status enum status enum and it can either be good or bad, which basically means if during a certain window the status of a tick is bad, a validator is telling you that I can't reach the website, might be you may or may not add this. Basically let me not add this only. Like if you have all the ticks in the end, if you have the ticks for the last 30 minutes, you can take the recent 5 ticks and figure out if the website is down or not. In our case, it's very hard to tell when do you say the website is down. Is it when one validator says it's down? Is it when 30% of the validators say it's down? So on the front end, we'll just do magic with this website tick. We'll just see the last 10 ticks, and based on that on the front end, we'll decide, is this a up website or is this a down website? Cool. So let's implement the status endpoint. Assume the user will hit this with a query parameter, so something like this: website ID equal to 123. So assuming the user is going to send us the website ID like this: const website ID equal to rec.query.website ID. And now we just need to return the latest ticks for it. So maybe the URL as well. So const data equal to await Prisma client dot db dot dot website dot find first, where ID is website ID, and include the ticks as well. So what are we saying? We're saying, okay, return me all the data for this website along with the ticks. Also website ID needs to be information. One more security detail here is, okay, you should make sure, okay, this is not an open endpoint. I should not be able to get someone else's website tick data. That's insecure. I guess, yeah, that's insecure. If another company is tracking their website, I shouldn't be able to hit their website, this endpoint with their website ID and get back their data. And you can restrict this by doing something like this. You can say here ID should be this and the user ID should be this. So this person should actually own this specific website. Only then will we return the data. Otherwise, this will return an empty row, and that would mean the user gets back no data. There's still a type error here. Yeah, so let's give this a explicit type. String, or let's do this as unknown as string. Basically, query parameters can be strings or string array, a bunch of things. If I give a query param 2 times, a equal to b and a equal to b, then it becomes an array, right? Something like this, an array with value b and c. So it can be a bunch of things. We're assuming the user will not send us a naughty value. Ideally, you should add validation over here, use something like sort. We're not doing that. We're just assuming the type will be string, and then TypeScript is happy. So get back the data, that's the website URL as well as the ticks, and return them to the user. Rest.json. I don't know if data is the right field. Maybe we should just return it like this. Yeah, return the data as such to the end user, whose type will look something like this. It'll have an array of ticks, and it'll have things like this: the ID, the URL, and the user ID. Cool. That's the second endpoint. Of course, we'll test it. We don't know if it works immediately. When we reach the front end, we'll test it. Website. So I need to get back all my websites. So user ID equal to rec.user ID, and wait. So this is where you should now start to use AI and not shy away from it. If you can write 2 of them, AI can write the other 2 for you, and that is fine. I'm not going to, but I'm just saying website dot find all or find many, where user ID is this thing. That's good enough. Const websites equal to this thing. Yep, and delete would just delete the row. So here comes another mildly controversial concept, but you should usually not delete things from your database. You should just have a field called disabled boolean, which at default false. So when someone deletes it, just disable it in the database. That would mean when they're getting their websites, you should only get the websites where disabled is false. And when they're deleting it, const website ID equal to rec.body.website ID, const user ID equal to rec.user ID, and here we should do a await Prisma client dot website dot update, where ID is website ID, user ID is user ID, and we should set disabled to be true, something like this. Rest.json message deleted website successfully, something like this. Now you're seeing a bunch of red squigglies, and that's because I have updated the database. I have added the disabled field here, but I haven't yet migrated the database. I haven't yet generated the client. That is why you see a red squiggly here, because it's saying the disabled doesn't exist in the client. Same is true over here. So we need to regenerate the client, re-migrate the database. Only then the errors will go away, but hopefully the code is readable. Acha, yahan pe we're just setting the website to be disabled. Yahan pe we're only returning the websites that are not disabled. The disabled websites you don't have to return to the front end because the user has deleted them. In their memory, that they're gone. So they should never see them on the front end, which means whenever they hit this endpoint, they should not see that specific website. All right, time to do a cd packages db. 1x Prisma generate, 1x Prisma migrate dev. That should migrate the database. I'm going to call it added underscore disabled. What that does is I'm just telling you what change have I made. And if you look at the migrations, now we have a init migration. We have a added underscore disabled migration. You can keep adding more. This one, if you look at it, what does it do? Alter table website, add column disable, boolean not null. By default, it is false. So our table is now migrated, our client is now generated, and the squigglies are gone now. We initialize a website. We don't set disable to, excuse me, false here because the default value is false. So this is still fine. When we're getting a website status, again, we should probably set disable to false here. A user should not be able to get the status of a website that's dead. So that's another thing we should do. And simply here, a deleted row shouldn't be returned, everything else should be returned. And lastly, delete should actually delete everything from that specific row. Sorry, it should not delete it. It should set disable to true. We're assuming that's deleted for all practical purposes. Front end where the user doesn't see it, the user thinks it's deleted. For audit purposes, generally it's a good idea to not actually delete the row. There'll be another problem here if you can already guess. Okay, there'll be foreign key relationships. So we need to cascade the delete. If we're deleting a row in the website table, we have to delete a lot of rows in the website ticks table as well. Wherever the relationship exists, all of those rows need to go as well. That's simple to do, but to avoid that for now, we've done this. Cool. That's all for CRUD, it seems. The next part is going to be authentication, which means we'll have to write a little bit of the front end. Or should we defer that and now focus on the hub and the validator? Let's do the front end. Let's quickly finish the front end. Clerk should be very easy to add. We'll generate the website using bolt or lovable. So it shouldn't take more than 2 minutes to create a skeleton of the front end. We don't have any ticks right now. Ticks will not propagate. For that, we need the hubs and the validator implementation. But let's do the front end first. Let's quickly finish it. Shouldn't take more than, I don't know, AI writes it maybe 20 minutes. But before that, before we write the complete front end, let's do authentication. So in the next section, we're going to focus on authentication using Clerk. All right, let's get into the front end next. I have gotten rid of the web folder. Let's create a fresh Next.js application, which has Tailwind as the styling framework and ShadCN as the UI library. It will make it easier for us to have a few components in there. For installation, you can go to ui.shadcn.com/docs/installation/next. This is how you initialize a fresh Next.js repo in the apps folder with ShadCN installed and Tailwind installed. While that is happening, oopsie daisy. I want to use Next.js. The name is Frontend. And while that is happening, let me take you through Clerk. Clerk is an authentication as a service platform. It'll make it easy for us to add authentication, log in with Google, phone numbers, emails. It'll handle all the headache for us and very easy integration with our Node.js backend. So at this point, you should sign up to clerk.com, create a new application. Let's call it Decentra or Deepin Uptime. That's a decent name. Let's select email and Google as the default options for now. So this is what the sign-in page would look like eventually. Let's see if the something went wrong in installing a Next.js project. Oh boy, feel like I've seen this before. It might have already installed. Let's see, localhost colon 3000. I do see the Next.js boilerplate. And if I go to frontend/app/page.tsx, seems like Tailwind is working. Let me just quickly see if ShadCN is working as well. So let me add the button component from ShadCN. For that, you run the command bunx --bun ShadCN at latest, add the button component. And let's try to see if you need a components.json, write into components.json. And if I use the button, let's say sign up from ShadCN, do I see it? Let's see. On the front end, I do see a pretty button which comes from ShadCN. So we're good to go. The front end installation is done. Next up, I created an application on Clerk. And if you go through the Next.js docs, it's very easy, the things that you have to follow to add a Clerk-based authentication, front end, back end, everything to Next.js. Even though we don't need backend over here, we're not using Next.js as our primary backend. But for the front end bits, we can run npm install at clerk/Next.js. We can copy the environment variables, a public key and a secret key to our .env file. So let's, in the front end folder, create a .env file where I've pasted my Clerk secret and public key. I will of course replace this by the time the video ends, but it's also a development key right now, so nothing, it wouldn't matter too much. Update middleware.ts. This is mostly needed for when we have backend that uses Next.js. We're not doing that, so we'll add it here. We don't really need it. And then lastly, add a Clerk provider. So let me copy this import. Let me not paste it in app/page.tsx. Let's create a fresh component called app bar.tsx, as in a top bar like this for our website, where the user sees the sign in button and the sign up button. So here I'm going to import Clerk. I'm going to export the app bar component. I'll wrap the app bar component inside a Clerk provider. I probably should do this in layout.tsx. Should I? Yes, I probably should wrap my complete application inside the Clerk provider. So let me copy the Clerk provider import here. Let me go to app/layout.tsx. And यहाँ पे I'll wrap my application inside a Clerk provider. And I'll also add the app bar over here. This app bar that comes from components/app bar. So now my layout, which means every page of my website, is wrapped inside the Clerk provider. So it will have all the authentication things in there and also has an app bar at the top. So यहाँ पे I can remove the Clerk provider and simply return a div where on the left it says deepen uptime. That's going to be, the logo of our website. And on the right, we add this code, which you can find over here as well. What does this code do? It says if the user is signed out, I repeat, if the user is signed out, then render the sign in button and the sign up button. If the user is signed in, then render the user button, which will be like a profile button that the user can see. So the app bar is now created where we have deepen uptime written on the left. We have a sign in, sign up button on the right, or we might have the user's profile if the user is logged in. Let's see, does it work? Let me start the application. Let me go to localhost :3000. And we see an error, probably because we need to convert. Auth was called, but Clerk hasn't detected use of Clerk middleware. Please ensure the middleware exists at /middleware.ts. Pretty sure I added that. The only other thing I can think of is this needs to be a client component. Yeah, and that's it. I had to convert app bar to be a client component because most probably this sign out component or sign in component need to be rendered on the browser. And hence, once I did that, I see sign in, sign up on the right. I can make these buttons prettier. If I click on it, this is the best part about Clerk. Okay, it handles authentication for me. If I click on login with Google or continue with Google, I don't have to worry about the auth keys, the client ID, client secret. Eventually, we have to worry about them. But for bootstrapping your application, it adds authentication fairly quickly. And when I reach back localhost :3000, you will see I have a profile button over here, which has everything. So I can manage my account, change my email, log out, so on and so forth. So this is the benefit of using Clerk. Now we have the app bar that is done. We probably need to render some, basic boilerplate code over here. So what will we do? We'll depend on a front-end AI to code it for us. So let's make the AI code a landing page for my better uptime monitoring platform. And let's see what it gives us. Hopefully it gives us a pretty enough page that we can just copy over. One more thing that might be good to add is a dark theme. So for that, you can go to the theming section over here in ShatCN and or dark mode over here for Next.js. Let's install next themes to our project. So bun add next themes. We have to create a fresh component called theme provider.ts. Let me do it here in components theme-provider.tsx. If you look at it, it's nothing but wrapping the application inside this next themes provider. But this next theme provider requires to be rendered in a client component. The reason we had to create this providers.tsx or theme provider.tsx separately is because in layout.tsx, I can't simply write next theme provider. ये मैं यहाँ नहीं डाल सकता हूँ because next theme provider is a client component. It needs to be rendered on the browser, and hence if I add it over here, I'll have to make the layout a client component, which is something you can't do. So this is standard practice. If I quickly show you github.com/code100x/cms, this is also a Next.js repository. And you will notice if I go to source/app, in the layout.tsx here as well, we have something called providers, which is a separate component. Providers is a separate component which comes from, let's see, where does it come from? /providers.tsx. So if I open /providers.tsx, what do I see? I see a bunch of providers rendered one after the other, the ones that require it to be a client component. So if you have a bunch of these context APIs, a bunch of these components that need to wrap your application, but they need to be on the client, you have to create a separate file for them called providers.tsx, or in our case, we have created theme providers.tsx. I've added use client at the top. I've wrapped my application inside this, next theme provider. And this theme provider is what I will use over here. Theme provider. And then the theme would flow throughout my application. What do we want? We want dark mode is enabled. So theme provider default theme equal to dark. And that should probably do it. That should enforce dark theme throughout our application, which is something we want. We just want a dark mode application. If I open this again and refresh, you will see the application is in dark mode now. Everything is black. Great, beautiful. ठीक है जी. So now let's see what Bolt created. It created it in white mode. So dark mode, please. But it looks pretty good. I don't hate this landing page. That's why I like these applications. Great for creating, a very first version of your application. While it is creating it, let me see what we need to do next. What do we need to do next? We need to create a dashboard page. After the user signs in, they should probably go to the dashboard page. So let me create a front-end app / dashboard. Hey, oopsie daisy. Did I delete the app folder? Seems like I did. That's not great. I deleted the app folder, did I? Yep, I deleted the app folder. Pause time. Let me rebootstrap it and add everything there. All right, the app folder is back in. This is what we have. Let's create the dashboard route really quickly. So app/dashboard, oopsie daisy, /page.tsx, which again, honestly, I would like Bolt to code, but we'll see. I asked it to make it dark mode. Why is it not dark mode? Okay, I don't know. But let's see what it created. It created a very big app thingy for me. Let me copy it. Let me paste it. What does it use? It uses Lucid React, which is a icons library. That's the only extra thing they added. So we'll add that to our code base. We'll replace our landing page with these guys and hope it just works. I think it should. Seems like we already have Lucid React. Let's see. What does a landing page look like? Probably need to make this a client component. And refresh. Yeah, it looks pretty good. I can remove their app bar, which is this nav bar right here. Oopsie daisy. Refresh. And there you go. We have a mildly, decent looking landing page. Great. Let's build the dashboard next. So I'll go to front-end app dashboard /page.tsx, and my trusted friend, I'll create a new one, bolt.new. And so I need a dashboard page. Give me the dashboard page for a better uptime like platform, which shows the websites that I have. If I click on them, an accordion should open, and I should see the uptime ticks for the last, let's say 30 minutes, 10 lines, green or red. I should also see the overall status in a circle, red or green. All right. Hoping this is easy for it to code while it is coding it. I created dashboard.tsx, dashboard/page.tsx. Honestly, that might be it. We just need 2 pages. Eventually, we need to connect it to the backend. That's a whole different story. But let's see what it cooks. And while it's cooking, let me write a bunch of hooks to connect to the backend. So let me create a new folder called hooks, inside which I'll add the first one, which is going to be use websites.tsx, export function use websites. Const user equal to use user, that probably comes from Clerk. Yeah, all of this is great if you were using tan stack query. We aren't. So const get author equal to use auth, which comes from Clerk. And I'll add an effect over here, which will do const auth equal to get auth. And it'll do a, let me add Axios as a dependency. One add Axios. It'll hit our backend. So Axios dot what is our backend endpoint? It's localhost Corinth. I don't remember. What is the backend endpoint? Let's make it 8080, shall we? And here I'm going to add not this, but backend underscore API backend URL. Let me create a new file called config.tsx in frontend, or config.ts, where I'll add export const API backend URL is localhost 8080. I will import it over here. And I think this is right. API v1 websites. That's what we had in index.ts, right? This is where TRPC helps, by the way, but yes. API v1 websites, that's what we have here. Const response equal to await this. Since we want an async use effect, I have to do this. Hopefully this is simple enough. You can't really, this function can't be async. And hence inside this, we create a closure, which is async, which we immediately call over here. And yeah, I write get auth const response. Actually, I should do something else. Let me get rid of all of this. Let me create a function called refresh websites, where I write all of this code. Inside this use effect, I'm going to call refresh websites and set an interval. Okay, every 5 minutes, maybe 1 minute. Every 1 minute, I want to refresh websites, see the updates that have come. Have they gone down? Have they gone up? Have I added a new website? And set that in state. So I'm going to introduce a state variable here. Get auth is not a function. Use auth. What does it return? Get token. My bad. So this is going to be not get auth but get token. And here I'm going to write authorization bearer space token. You can also just write the token to keep things simple. Something like this. The token is what we forward to the backend in an authorization header. Cool. What's the problem here? I need to await this. And I need to create a state variable called const websites, set websites equal to use state websites. I need to create an interface called website, which has ID URL status. Status, not really. It'll have ID URL and it'll have all the ticks. If you remember, what does the endpoint return? The endpoint returns the website data. Oh, it doesn't have include the ticks. We should include those. I think we're doing it here. Include ticks. We should do that here as well. There we go. Okay, we have all the ticks of the websites being returned. So it will have ticks ID created at status latency. That looks perfect. cool. Oh, we'll have to write a bunch of front-end logic to aggregate the ticks. If someone had a tick at 301 and then someone had it at 359, whatever, 301, you get the idea, right? Someone might have a tick at 0300 p.m. Someone might have it at 030001. That's the hour, the minute, and the second. Someone might have it at 030002. In सबको aggregate करना होगा to create the single tick. If 5 validators tell us, okay, you know, at 3 p.m. के आसपास, someone says it was up, someone says it was down, we need to aggregate them, and that will decide the first tick, and then the second tick, and then the third tick. We'll have 3-minute windows most probably. So 3-minute windows की ticks will be aggregated directly on the front end. Let's import use state. Let's make this a client component. And set websites response.data.websites, which is exactly what we return over here. Use effect and return websites. Yeah, that's good enough. Maybe one more thing we should add is loading, like a loading state, but okay, I'm just returning it as such. I've created a use websites hook. Let's see what Bolt created for us. Whoa, beautiful. Exactly what we fucking needed. Add a create button as well. Create a website button as well. Make sure to add dark mode. While that is happening, this is exactly what we needed. Beautiful. I love these guys. So let's make it do it. I mean, it's like a very good V1, right? You can always iterate. You will, if you want to finesse the product, good to have engineers who do it. But a V1 MVP, great to ship out using this. All right. So these uptime ticks will change based on, you know, the data from our backend, but that's fine. Hardcore data is good enough for now. And this is great. We have a pretty looking component for us. Let's wait for it to finish, and let's create or slash go to the app slash. Actually, I want to test Bolt and see if I create a file here. Can I do that? I can. Called use website. Oh, daisy. Create a file here called, delete this one, use website.ts, and paste this code over here and ask it, I've added the use website hook. Use it to render the data. Ticks should be aggregated on 3-minute windows based on the created at field. If it does this, I'll be impressed. Let's see. Now I suddenly am, so I'm not sure if you guys know, but we're building something similar on app.antidevs.com. And oh, it's down. But basically, there are a few approaches to do what Bolt is doing over here. And you know, the one that they've taken, which is basically doing all of this on the front end, is debatable if it's good or not. But if it works over here, I'll actually, you know, agree to the fact that what they've done is really good. Because in our approach, it's a little hard to add user code to the AI. I added some code here, right? Use websites.ts. Integrating this to the AI gets a little tricky. Let's see if they can do it. Of course, it's down because, you know, this isn't, config isn't a folder here. But if I open main.tsx, app.tsx, let's see what they've done. Status circles, uptime ticks, create website model to create a new website where you can add a website, and processed website is probably, you know, whether the status is up or down. It's processed from the ticks website card. Then finally, websites use websites. Process websites equal to use memo. Websites.map, sorted ticks is this thing. 30 minutes ago is this thing. Recent ticks is filtered window. Windows this thing. End equal to this thing. Window ticks dot filter tick time equal to new date. Tick time equal to window start, window end. So recent ticks. Where does recent ticks come from? Sorted ticks dot filter date dot tick is greater than 30 minutes ago. Okay. Every tick that's greater than 30 minutes ago. Window ticks equal to recent ticks dot filter. Tick time equal to this thing. Tick time is greater than equal to window start, less than equal to, so what does window start? Okay, there you go. 10 ticks for, they've just divided the 30-minute window into 10 parts. Beautiful. And you know, created this window ticks variable that, you know, has the aggregated data for those specific windows. Up ticks equal to window ticks dot filter, tick dot state is equal to up dot length. Windows of 9 minus I. Oh, what is this line? Equal to windows dot length equal to 0 comma true up tick. If there is no tick in that window, what is the? Why does it start at 9 minus I? Windows, where does windows come from? When do you push to the window? Windows is an empty array here. And they're simply doing windows of 9 minus I here, which is fine. Like in an empty array, you don't necessarily have to push. You can just, put something at an index. So they're just putting something at a index 9, index 8, index 7, index 6, which is fine because sorted hai, ulta sorted hai. The recent thing comes towards the end. The latest thing comes, the most oldest thing comes towards the beginning. So this windows array will be populated eventually from index 0 to index 9 with, true or false based on us window mein jitne ticks the, majority were true ticks or false ticks. Beautiful. Total ticks is this thing, up ticks is this thing, up time percentage is this thing. Current status is if the 0th tick, which is the most latest tick, if it is up, then otherwise down, and then it returns all of this data. Use effect outside a component, or is this inside a component? It is inside a component, makes sense. And then yahan pe there is, we'll see what it is, but it's probably just a button to add a website, and then all the websites rendered one after the other. Where does create website model? It's in this folder, only website card in this folder. All right, beautiful, copy the thing, go to app dashboard page.tsx, paste it. This comes from someplace else, beautiful, and that's it. Oh boy, I'd be super impressed if this works. I mean, it'll probably work. Looking at the logic the first time, it seems like it's perfect. Let's see if that is the case. Of course, our backend is down right now, so maybe let's start the backend as well. Let's start the backend. It will return empty data. We don't have any data populated at the moment, but still let's start the backend app/API and bun index.ts. It says auth middleware not found here. Exported name auth middleware not found in deepin apps API middleware.ts. So middleware.ts. Oh, I replaced the wrong middleware. That's why it wasn't working. I replaced it in the wrong middleware before when I was adding it to Next.js, but doesn't matter. Now I have updated the right middleware.ts with the auth middle. Sorry, reverted the middleware.ts yahan pe, and frontend main. Do I have a middleware.ts? I thought I should. It seems like I don't. Basically, when you go through the Clerk, this thing setup procedure, it asks you to update. Oh, CDC, it went away. But if you remember when the setup procedure we were going through, overview, configure your application. When we were going through the setup procedure, it asked us to update middleware.ts here. That is usually needed if your backend is in Next.js. Our backend is not in Next.js, which is why even if we did not add it here, it worked. But if your backend is in Next.js and you want authentication there, आपको middleware.ts यहाँ भी लाना पड़ेगा. I did the mistake of updating my backend का middleware.ts with this, which is why we saw an error. This is what I added by mistake, and now I've reverted it back to our original thing. Hopefully that's clear what happened over here. But index.ts to restart. If I go back here to /dashboard, moment of truth, let's see what Bolt created for us. The first thing I have to do is convert this to a client component. Use client. And all right, that looks pretty decent. I see uptime monitor over here. I see dark mode, light mode toggle over here. I see add website here. I can add a website. The name of the website, don't really need the name of the website already. So, let's get rid of this completely. Just the URL is good enough. And yeah, URL, click on add website. That should add the website over here. Of course, we have to hook it up to the backend, but seems like this is great. Let's add a few things. Let's finish the add website, thingy over here, connect it to the backend. Let's add some dummy data to the backend as well and see how the front end is performing on some dummy data. Eventually, the data will be propagated by validators. Abhikli, I'll add some data in there manually just to see if front end is working as expected or not. So let's get into that next. All right, let's quickly connect the add website button, this one right here, to the backend. So what I'm going to do is I am going to add a state variable here called const URL comma set URL is useState, input value is URL, on change is set URL, and the button on click calls on close, which will close the modal, but also needs to do one more thing, is call the backend and hit an endpoint over there. So let's say on close takes something as an input, which is the URL of the website you're trying to monitor, string, and yahan pe I'm going to add on close is on close of URL. Perfect. Yahan pe I'll get URL as an input, and I need to do a axios dot post slash websites with the URL. Is that it though? Let's see, package.json. No, index.ts post to slash API v1 website, API v1 website, and also need to add the authentication header here. So const token is get token, async, use auth. Love this tabbing thingy. Yeah, it takes me to the right places. Beautiful. Get token comes as an import over here, and whenever in the website model I click on the submit button, on close gets called, which gets the token of the user, closes the model, and sends a backend request to do this. We should probably first send the backend request, and only if it succeeds to it, either is fine. So let's do this. One thing we need to do right after is refresh the websites. So this refresh websites button I can add in my use websites hook. Yahan pe this refresh websites is something that we need to return from here along with the websites, so that as time goes by I can keep refreshing websites, which means keep getting the fresh set of websites from the backend, especially needed when we create something new in the backend. Alrighty, so refresh websites should come from the hook. Where is the hook? The hook is over here. Const websites comma refresh websites is this thing, and then we're good to go. Yeah, that looks good. The backend is up. Is the database up? The database is up. Let's see if the application just works. Of course, there's empty data right now, but I should be able to add websites here, right? So if I do google.com and click on add website, it refreshes the page, which is something we don't want. So let's get rid of the form over here. Try it one more time. Add website, google.com, and right click, inspect network, add website. Does nothing. It does nothing probably because Clerk is not returning us data. That would be my guess. Okay, Clerk is not responding. Add website, put something random here. A bunch of CORS errors to begin with. So let's quickly add CORS to our backend. Did I not fix this already? Save. It does the auth middleware here. Restart TypeScript server. That fixes it. Import. I would import CORS from CORS. I would do app.use CORS, and I will add one add, not to the front end, but the backend. I'm going to add CORS as a dependency. There we go. And let me start the backend, bun index.ts. Now let's refresh, and hopefully the CORS error goes away. The website's endpoint does get called. It returns most probably empty data right now. We don't have any websites. Now let's see what happens when I click on add website. Put some data, click on add website, does nothing. So let's go back to the front end. Add website button on click calls this. Oh, add website. Oh, the other one, add website. Yeah. I need to add on click here as well. यहाँ पे I'll do an on click of null or on close of null. So यहाँ पे I'll say on close can return either a string or a null. And यहाँ पे I'll add logic कि if the URL is null, that means the user has just closed the window. They don't want anything else. They just clicked here. So I don't want to send a backend request then. But if the user does this, google.com, and if I click on add website now, the website does, we hit the backend endpoint, it returns the data, and I see, whatever, google.com over here. Now, we don't have any data. This is sort of wrong. We should only show ticks if they exist. So we'll fix that soon. But first, let's put some dummy data in the backend and see, what does the dummy data return. Surprisingly, it's green over here and red over here. That's very weird. So let's look at some code that AI wrote and try to fix it. This will be the hardest bit. Making AI write code is easy. Fixing it is the harder bit. So let's see how hard is it's going to be to do this. So सबसे पहले processed websites equal to use memo. Sorted ticks, that sounds good. 30 minutes ago, that sounds good. Recent ticks is the ticks from the last 30 minutes. Aggregate them into 3-minute windows, 10 windows total, perfect. Window start equal to this thing, window end equal to this thing. Window ticks equal to recent ticks dot filter to filter tick dot equal to up dot length. So here we need 3 statuses here. It'll either be true, it'll not be Boolean, it'll be an array of statuses. So, status which can either be good or bad or unknown. Unknown basically means that during that 3-minute window, no tick is there. No validator was able to, do it, which is currently happening. We don't have a validator right now. These should all be gray. The last 30 minutes, we don't know what the status was because no validator is validating this website right now. So 3 statuses we have added over here. And here we'll say that if the window length is 0, then it will be gray because we don't know if the user has, no one has validated the website during that window. Otherwise, it will be, if it is greater than 0.5, then it will be green or, whatever, good. Otherwise, it will be bad. Perfect. What's the problem here? Good, bad, or gray. So let's not make it gray. Let's call it unknown. Good, bad, unknown is not assignable to unknown. Alrighty. There we go. It's an array of good or bad or unknown. And when we are current status should be sorted to 0 equal to up, then up, else it should just be this. It can be either, current status can either be not as up and down, it will be as whatever. Let's rename this to tick. Interface, there you go, or type uptime status, good, bad, or unknown. So यहाँ पे I will say status is process website, uptime ticks is a uptime status array, and यहाँ पे status circle, where was that? We'll fix this later. Let's first look at this guy. This will be an array of uptime status, and यहाँ पे I'll return current status as uptime status. So I think that will already happen. Current status is sorted ticks of I of 0. What is sorted ticks? Website.ticks. Current status is sorted ticks of 0. What is sorted ticks? It's this. It'll be windows of 0, I would say. Yeah. And yeah, so we'll return current status, which will be uptime status. Perfect. This is the current status, which is the 0th window pe kya value hai, which means the recent window, what value does it have? Will it be the recent one or the last one? Let's see. I don't know, one of these two. We'll see which one. Cool. That should do it. There There are some red squigglies in a bunch of places. Status is website.status. So up or down is not assignable to this thing. So status circle, what do you expect? Uptime status, what do you expect? Good, bad, or this thing? What is website? So website status is going to be uptime status, not up or down. It could be up, it could be down, it could be gray. Almost all red squigglies are gone other than this one. Uptime status array is not assignable to Boolean array. So uptime ticks will not be a Boolean array, but a uptime status array. And यहाँ पे we need to enter all the ticks, but there you go. Tick is good, then green. Tick is bad, then red. Otherwise, gray. So if there is no processing happening, gray is what should be rendered. So now if you see, all of these are gray. In the last 30 minutes, I haven't processed anything. And this overall status is also gray. I think of I is wrong. Of 0 is... This is wrong. Current status should be windows of windows.length -1. It should be the last thing. Current status is आखिरी वो क्या है. This tick is gray, then overall status is also gray. If this tick is green, then overall status should also be green. Alrighty, beautiful. Now let's seed some data in our database. Let's put some things in there just to make sure, you know, we can test this on the front end and everything is working. So the standard way to do that is add a seed.ts file here in db/seed.ts. And यहाँ पे you can, you know, import Prisma client from Prisma client, and we can start to see data, which could be, you know, put some user in there, let's say with ID 1. Or since I want to test this, actually it doesn't matter. What is our middleware right now? Middleware returns ID 1. This is fine. And let's add a few ticks. Let's add a website called test.com. Let's add a few ticks. Okay, website ID 1 status is good. Created at is the current time, latency is 100. Let's add another tick, new date minus, you know, this is 1 day ago, this is 1 hour ago, and this is 10 minutes ago, which is what we want. Okay, 10 minutes ago there was a good status, and another 10 minutes ago, let's say there was a bad status. So 20 minutes ago there was a bad status. And currently the status is good. That's good enough. 3 entries and ticks is great for now. We can eventually add more. So yeah, that's good enough for the seed file. What is the seed file? It seeds the data in your database, which means put some dummy data in there for your testing purposes. Let's do a cd.cd packages/db npx prisma seed or db seed, I think. I need to add this to my package.json. So let me add this prisma seed ./seed.ts, and let me try that one more time. Unknown command ./seed.ts package.json and db. It does exist here. So let's put it in Prisma folder, and let's do ./prisma/seed.ts. Try it again. Command error occurred. Spawn e-access. ./prisma 1 ./prisma /seed.ts. Cannot find ./source/client. So one big problem here is, okay, this is not going to be in ./source, but ./source/client. Restart TypeScript server. Yeah, there you go. Refresh. ये भी exist नहीं करता है, क्यों? ./source/index.ts. My bad. And password की जरूरत नहीं है. Our users table doesn't have a password. Ticks में क्या issue है? .website tick status good, website tick status good. And do we need something else? Why is this throwing an error? We don't have this thing. Validator ID is missing. Of course, to create this we also need a validator. So let's quickly create one. Await, create a validator called test validator. I don't think the name matters. The public key is what we need, which could be a random public key for now. User ID not needed. what's missing here is location and IP. So let's say location Delhi, and IP for now is 127.0.0.1. Const validator equal to this thing, and then everywhere we can add a validator ID. Perfect. Validator ID. Perfect. Website tick, status bad, validator ID. Perfect. All right, let's do it again. 𝗠𝘁𝗶𝗹𝘀 Prisma DB seed. Wrong folder. Do I need to change permissions on this file or something? You need TS node to be installed. Oh, this is for that guy. Let's try 𝗠./prisma/seed.ts, and that looks like a better error. What's the error here? Unique constraint failed on ID. Website tick. Oh, we're giving IDs over here. We shouldn't do that. Shouldn't do that here either. Yahan pe we should add an ID. Everywhere else we shouldn't. And now if I run it, again an error comes this time. Unique constraint failed on user ID. Oh, my bad. User ID should also be. I'll just change it to 2 for now. Run it. Great. Database has been migrated. For the user with ID 2, now we have a website called test.com and a bunch of data in the database. So now in my middleware.ts, let me hard code the user ID to 2 just for testing purposes and make sure the database returns the right values. Let me restart the backend. Let me go to the front end. Don't have to do anything here. Refresh and nothing happens. Why is that? Network tab. This returns a 200 with empty websites. Rec.user ID is hard coded to 2 here. In my seed.ts, user ID is hard coded to 2 here. User ID 2 पे website बनेगी, user ID 1 पे नहीं. Let me just do this. Const user underscore ID equal to 3. And यहाँ पे I'll add user underscore ID. Here I'll add user underscore ID. And validator is just create a new one. Yeah, let's see the database again. Oh God. Website ID also needs to be unique. So do we really, when we're creating the website, let's not hard code the ID. Const website equal to this thing. And let's replace this with website.id. Replace this with website.id. Replace this with website.id. User ID, let's make it 4 right now. That should be fine. Let's seed the database. Database has seeded with a user with ID 4. Middleware.ts, replace the ID to be 4. Restart the backend. Try it again. Refresh. And I get test.com. And it shows me 1 tick over here bad, 1 tick over here bad, 1 tick over here bad. And overall status is bad as well. So this is being picked over here. That's good. But the problem is the data that I seeded had the status as good over here, and then bad over here. So in our dashboard, what are we expecting it to return? Tick.status can be not up or down. It will be good or bad. Yeah, that looks good. There we go. 2 of them are good, 1 of them is bad. Overall status is good. Beautiful. That's our first monitor. If I want, I can add another monitor. Google.com. It'll of course initialize to an empty ticks. So, no tick data, no status over here. But slowly as validators propagate, update our database, we'll see green and red over here. Beautiful. 0% uptime looks wrong over here. So uptime calculation is a little incorrect. Percentage is Total text is 0,100. Otherwise, upticks divided by total text. So upticks is good.length. And now wait, this upticks variable is status is good. Yeah, that looks good. 66.7% uptime. So 1, 2, and 2 of them were up, one of them the text was down. So 66.7% uptime sounds beautiful. Great, I can add more websites. I see this says 100% uptime here, which isn't best. It should say unknown because it is unknown, but that's fine. Front end is done. We have a landing page that looks something like this. Start monitoring. Whenever you click on this, you should probably go to the dashboard page. So I've added user router hook. I've added the router. I've created a router instance which calls the user router hook, and I've called router.push over here. If I go to the landing page and click on start monitoring, I see my dashboard, and I can see the good ticks, the bad ticks, and go from there. If I wait for 10 minutes, I'll see, or 3 minutes. If I wait for 3 minutes, I should have seen this pushed back a little. I would have expected after 3 more minutes, this green will reach here and then the current status will become gray. This red will push here because every 3 minutes, we're slowly moving back a bit. Okay? Beautiful. That covers the front end, the back end. One thing, last thing to change is update middleware.ts. We're receiving an auth header here. We're using Clerk for authentication. Clerk returns or gives you something called the JWT public key here. There are various ways to authenticate a user on the backend. The one that we're going to use is this JWT public key. Basically, the tokens that it's sending you, it's signing it using a private key. And that the corresponding public key of that private key you can get from here. Let me put this public key in the backend. API/config.ts. Export const JWT underscore public underscore key equal to process.env.jwt public key, or this very long public key that we have for my test project for now. And this JWT public key is what I can use to validate. So if not auth header, do this. How are we sending the header? If you remember, Axios dot, we're sending it in bearer space the token, and over here just the token. So let's stick to one. Let's keep things simple and remove bearer. Just send the token in the authorization header. So यहाँ पे the token is simply this. The frontend is not returning us bearer space token. Frontend is simply returning us the full token. वो token यहाँ आ गया. Now we number one need to add JWT as a dependency. Once that is added, import JWT from JWT. Oh, sorry, it's not JWT. It's called JSON web token. Let me add that as a dependency. One add JSON web token at types / JSON web token. And this comes from the config.ts file. Decoded equal to JWT.verify token. If it is correct, then rec.userid is decoded.sub. And next, if not decoded, or if not decoded.sub, that means the clerk did not return us anything. The user is not logged in, the token is invalid. Then we return a 401 status code. We can actually log. Let me just log decoded here. So you can see what it looks like. And there's a type error here. As string is fine. Let's log decoded here and see what it returns. I'm sure you're a little confused. What is this decoded? What does the JWT get decoded to? So let's try to debug the JWT that Clerk returns us, that we're sending to the backend, and see what kaisi dikhti hai and what we're doing over here. Alrighty, I've logged decoded over here. The front end is running. The backend I'm going to start, bun index.ts. Let me go to the front end and let me send a request. Something up here, we need to figure out the dark mode. When I click on add website, this is what Clerk returns us. This is what gets logged. This is what we decode from the token. And as you can see, there's a field here called sub, which means the user ID of this specific user. We don't want the session ID. We don't want who issued it. We don't want the expiry. We want what is the user that is, currently trying to sign into my website. So this is their user ID. And that is what we're going to put in this user ID field over here. That is what will get propagated to the user to the database. So now I indeed have a decently working website. I have no hard-coded data anywhere. I can add more websites here, google.com, and even if I log out and re-log back in, I'll see this data over here. So the CRUD functionality is done. The tick monitoring on the front end is done. The thing that is left is the validators actually validating the website, the hub telling the validators, okay, it's time for you to validate this website, the validator responding back. So let's get into that section next. All right, I've finished writing the hub and the validator as well. Until this point, we were able to do the front end and the API. The hub and the validator have their own set of challenges. I'm going to talk about those challenges and some architectural decisions very soon. But before we go there, let's look at the final website and how it looks right now. Here I've added 4 websites to monitor. One is an invalid website, and obviously all red squigglies here because this isn't a valid website. Google.com, everything green. 100access.com, everything green. Excalidraw, I just added like 2 minutes ago before I started recording, and hence you can see the first tick is populated because only 3 minutes ago we started to monitor the website. If I leave this on for another 30 minutes, you'll see all of them get propagated. If I want, I can add a new website here, for example, facebook.com, and that will begin to get monitored as well. Of course, initially it will be gray, but after 3 minutes, the next set of ticks will come in and you'll see the green and the reds based on whether or not this website is up. The question is how to build it. Do we remember the architecture? The API that I'm hitting whenever I'm creating a new website or whenever I'm refreshing and trying to get my existing list of websites, that API, simple, we've already built it. It's connected to a database. The front end is also done. The hub and the validator, if you remember, what did we discuss in the architecture? The hub will every 3 minutes, every 2 minutes, decide what websites to monitor, which basically means it'll hit the database and understand we have 30 websites to track, let's say, or 100 websites to track, or 1,000 websites to track. And it'll let all the validators know that. It'll run some sort of an algorithm. Okay, the first 10 websites I'll send to this guy, the next 10 websites I'll send to this guy, so on and so forth. Hopefully we have 1,000 validators. So, each validator does not have too much load or too many websites to validate. Each validator needs to validate, let's say, 20 websites every 3 minutes, something like that. The validator will receive this request, process it, and respond back with the status, which will get stored in the database. Whenever you come to the website and refresh, you'll again hit the API, you'll get the recent ticks from the database. You'll show them in the UI and you will see green or red ticks over here. And this is just a computed version of all the green and the red ticks. Based on the percentage, the final uptime appears over here. So the question is, how should the hub and the validator communicate? Should this be an HTTP protocol that makes them talk to each other? Should we follow a client server model? Does the hub need to send messages to the client? Yes. It'll need to tell the client, please do something. Does the client need to send a message to the hub? Yes. It needs to respond back. It needs to tell the hub initially when it comes up, okay, hey, I'm ready to take requests. So both of them need to talk to each other. Also, these validators could be people sitting on their home. They might not have a public IP yet. Like when you're running these machines, or when I'm running this validator on my local Mac machine, I don't really have a public IP or a dedicated public IP. I can punch through the network and get a public IP, but I don't have a dedicated public IP. I'm not always available somewhere. Hence, HTTP doesn't make sense. The hub will not be able to discover these clients very easily unless these clients are hosted on a cloud like DigitalOcean or AWS. If people are hosting this in their home, it's a good idea to not connect them via HTTP. If you can start an HTTP server here, you can start an HTTP server here, you can make them talk to each other via HTTP, but the hub it'll be a little hard for the hub to discover clients because these are random people on their houses. Hence, what is a better approach? Okay, the hub has a public IP. The hub is somewhere on the internet on a dedicated virtual machine. But these individual clients, they don't have their own public IPs. They are just connecting to the hub via WebSockets. Why WebSockets? Two-way communication. If this guy wants to initiate a message, the message will reach the hub. If this guy needs to initiate a message, it will reach the validator. So we're connecting both of them through a WebSocket connection so that there is two-way communication. Whenever the validator wants to respond back with something, it can. Whenever the hub wants to send a message here, it can. So that means we want to connect the hub and the validator through a WebSocket connection where the validator could initiate messages. For example, when the validator comes up, it will send a sign up message to the hub. It will tell the hub, hey, I am a new validator. I want to now start validating. I want to earn some crypto. So please register me and send me upcoming requests. The hub will store this in the database in their validators table and respond back. Tell them their validator ID. Is this called something? This is the client server architecture, right? A validator, a client is trying to talk to a server, hub, and waiting for a response. This is what we used to do in HTTP. WebSockets are usually not a client server model. You don't send a message and expect a response in return. But sometimes you do. For example, in this case. In this case, when you are sending a message, you want a corresponding response for that message. When you are telling the hub to sign up, you want the hub to tell you your validator ID. And similarly, after you are connected, the hub would like to initiate a message, okay, please validate api.100xdevs.com, please validate google.com. And then this validator needs to send a request to google.com, get a response, and respond back to the hub. So here again, there is a client server sort of a model. The hub being the client and the validator being the server. So when you want to do such two-way communication, when you want, if the hub sends, it could send 10 websites to validate, right? It might not just send one. It might send 10 requests to validate together. For every request, it expects a corresponding response message back. This isn't HTTP. In the hub, I won't write axios.get or fetch validator.100xdevs.com and wait for a response. It's not like this response field is populated from the response here. No, we're not connecting them via HTTP. We are connecting them via WebSockets, which means WebSockets don't have a request response model. They don't understand, I am sending one message, validate, for which I expect one message. The response, for this validate request, how long did it take for the validator to hit api.xyz.com? WebSockets don't really support this out of the box. So we have to build some sort of a, call it pattern, call it strategy in TypeScript to ensure such two-way communication. If we want, through WebSockets, if this is being the client, it expects the response for every message. If this is being the client, it also expects the response for every message. We need to introduce a new architecture that I'm calling callback-based communication. What am I calling it? Callback-based communication. If you've used Socket.io, it gives you this out of the box. It gives you a callbacks function that you can call to do something similar. We are not using Socket.io, we are using raw WebSockets. So we need to understand, when I send a request, when the hub responds back, how do I relate this response to the corresponding request I sent? I repeat, if this is the request I sent to sign up, server did its thing, put me in the database, returned me the validator ID. How do I know this response is corresponding to this request that I sent? Because I might send it 10 different requests to do 10 different things. The server will respond with 10 different responses. In WebSockets, the way we get back response is something like this: ws.onMessage equal to event, something like this, right? Const data equal to event dot data. The same callback is called for this message also, for this message also, for a third message also. If the hub is responding to the validator, sending a message to the validator, the same callback function is being called. We don't know this data is for this message, or is it a new message that the validator is sending us, sorry, the hub is sending us, or was it another message that I sent to the hub and it is responding back? So how do we relate outgoing messages to incoming messages? How do we make sure कि अगर मैंने एक message भेजा है, if I have sent a message, with the many messages I will get back from the hub, with the many messages that I will get back from the hub, which one of these messages, this one, corresponds to this specific request that I sent. Sort of a request response model. So here comes this concept of callback IDs. Whenever you want to send a message to the server, I repeat, whenever the validator wants to send a request here, let's say a sign up request. So sign up request, what all will it send to the hub? It might give it, its, let's say, name, its Solana address where it wants to get paid, or let's say bank address to keep its things simple, location, IP, things like these. Okay, I want to sign up with you as a validator. Along with all of these things that the user is sending, the name of the event, the data of the event, along with the name and the data, send one more thing. Send one more thing called the callback ID, a random UUID or a random ID. What does the architecture say? The architecture says, okay, send your messages normally. That is totally fine. Send whatever you want in this message. Send one more thing here, a callback ID. And the hub will ensure that whenever I receive a message, this is the message that the hub received. Whenever I receive a message, after I process it, I will respond back with my data, जो भी मुझे लौटाना है. I want to return the user their validator ID. They have signed up with us. This is their ID. And the callback ID they sent me. The callback ID they sent me when they send the request. So every request that you're sending via WebSockets, this request has the standard payload you would want them to have, plus a callback ID. Every response that's coming from here has the standard response it wanted to send and the same callback ID it's responding back for. So the validator, whenever it's initiating requests, it will send a random ID. It won't be 1, 2, 3. It will be like a very long random ID so that there are no collisions. The hub will process the request. Once it's done processing the request, it will respond back with the same callback ID. That's how the validator knows कि अच्छा ये request response, this response is for this corresponding request. The same is true for the other side. When the hub wants to send a message, for example, validate API.xyz.com, it will send a randomly generated callback ID. Here, when you are done processing this message, when the validator is done processing this message, the validator will respond back with the same callback ID and the response. Let's say, the status is good and the latency was 200 milliseconds to reach that specific website, api.xyz.com. So both the sides need to make sure that whenever they are receiving messages, they are fetching the callback ID from there. And whenever they are responding with the same callback ID. Whenever the hub sends a request, it needs to make sure it sends a random ID. And whenever this guy is done processing it, which in this case, it will just hit api.xyz.com, get the response, get the latency, get the status code, and respond back. This guy also needs to return the callback ID along with the standard payload it had to return. जो उसको normally लौटाना था वो तो लौटाएगा ही, plus साथ में जो request ID आई थी वो भी लौटा देगा. If you have a doctor's cabin and there are 20 people outside, you give them a unique ticket, right? And then you ask them, you come in. That's their random ID or their unique ID to identify the patient. So you can call patient number 1, patient number 2, patient number 3. Similarly, since there are many requests that can get bombarded to the validator, I might ask it to process 10 websites together. I'm giving every request a corresponding request ID so that when it responds back with the request ID. And I know what thing to do, because when it responds back here with callback ID 331, I understand on this server that I had sent him request to do this. He has responded back with this. So for api.xyz.com on this database, I want to store status is good, latency is 200 milliseconds. So that is how this hub knows that status is XYZ and what to store in this database. Let's look at the code and understand it a little bit better. This is one figure I haven't yet explained. An object, a global callbacks object, which looks like this. It has a key as a string and a value as a function. Do we understand this? You can always write this. Let me quickly show you. Let me create a new object. Let callbacks equal to 123, a function that does console.log hi there, and then 456, a function that does console.log hello. So if you look at the callbacks object now, its 123 key is a function, its 456 key is a function. If I do callbacks of 123, I get back a function. I have not called the function, I just got back the function signature. I can also call the function and then hi there gets printed on the screen. This is very important to understand before we proceed. In this architecture of callbacks and request IDs and callback IDs, we'll be using a global callbacks array that looks something like this. It will have a key, which will be the callback ID, and a function, which is what should get called when the other side responds with this callback ID. What are we going to do here? We are going to generate a random callback ID, generate the request, validate API.xyz.com, send the request over here. This guy will process it. And once it's done processing, it will respond back. That could take 1 minute, that could take 1 second, depends on how slow the validator is. When it responds, if it responds back with callback ID 331, what we want to do is, we simply want to call this function. We simply want to call callbacks of 321 like this. What that will do is, it will call this function where we will store कि क्या होना चाहिए जब दूसरी तरफ से response आए. What should happen when we receive a response from the other side is stored over here. So whenever we are initiating this request, whenever we are initiating the validate request, before we send the request, we actually populate this callbacks array. Here, whenever this request responds back, जब भी यहाँ से response आएगा, call this function over here, so that whenever this validator responds back, we simply have to call this callbacks of the callback ID, call that function, and that function already has what to do जब दूसरी जगह से response आ रहा है. Whenever the other side is responding back, what to do. So if you try to write this, it looks something like this. Okay, function send request. Whenever we are trying to send request to the other side, what do we want? There is a const global or callbacks array. There is a global callbacks array. We want कि first we generate a callback ID. Random string. Then we, rather than sending the request directly, what do? We say callbacks of callback ID equal to a function. So you can write it like this also. कि जब वहां से response आया, whenever the other side responds, store it in the database db.ticks.create whatever came back from the other side. Let's say status was good, so you'll just create another entry, status good, or whatever status that came from the other side. So let's say send request is send validate request for a specific URL, let's say google.com. So first we generate a random string, then we update the global callbacks array कि यार जब भी इसका response आया ना दूसरी side से, store this entry in the database कि for this URL, this is the status that the validator responded back with. This will not get called immediately. This is us storing in this a function. On this global callbacks array, or actually it should be an object, not an array. On this global callbacks object, we are saying callbacks of callback ID, this string is this function. Then we are sending it to the other side, okay, ws.send, whatever, validate this URL, whatever, we got in this function call, and the callback ID. We are sending this to the other side as well. So that's our hub ka code. This code is for the hub. What is the other side doing? What is the validator doing? Whenever it is receiving a request, so it's creating a connection to the hub. It is creating a WebSocket connection to the hub. So const ws equal to new WebSocket, whatever is the hub URL, hub.xyz.com. ws.on message. Whenever there is a message that is received, then let's say there is just one message we have. Okay, the validator will receive the message and hit that specific URL. So what data we get, we'll say const URL comma callback ID equal to data. Whatever data this guy is sending, I am going to receive here. I'll do a, whatever, axios.get URL. I'll hit the URL, I'll get the response. And if response.status code is 200, what do I do now? I need to send this back to the WebSocket server. So ws.send status is good and callback ID. Whatever callback ID this guy sent me, I am going to respond back with the same callback ID. So this message will go back here. And where will it be caught? It will be caught in the, there'll be a separate function, right? Const ws server equal to new ws server 8080, let's say. ws server dot on message. So now, whenever I get back a message from the other side, the server gets back a message, what do we want? We want क्या server ने message दिया है, इसमें there is a callback ID status. There is a callback ID that the validator responded back with. All I have to do is callbacks of callback ID को call कर देना. I just have to call this function. This is a little confusing. यहाँ पे I am sending the request to the other side कि यार ये URL validate करना है. The hub after 5 minutes realizes कि we need to validate google.com. So what will it do? It will call this function with google.com. Send validate request google.com. What happens first? We first generate a random string, a callback ID, a request ID. We store in the global callbacks array, callbacks of callback ID equal to a function where we eventually will update the database. Here I am defining a function, not calling it. It's getting called here eventually. Abhi ke liye I am just defining a function. And I'm sending this message to the other side. So the message gets received on the other side. The validator understands that this is the URL, this is the request ID. Let me send this request to google.com, get back a response. If the status code is 200, then I will respond back with status good, callback ID, whatever callback ID the user generated on the hub. I will respond back with that callback ID. Then it'll get received not over here, not in the send validate function. Ye to end ho gaya. But this callback still exists. The function ended, but this callback function that we had defined over here, it still exists in this global callbacks object. Yahan pe this function still exists. So whenever I respond back with a specific callback ID, we simply call that function. We call callbacks of callback ID, which was set over here, is getting called over here, so that this function gets called and the database entry eventually happens. That's the way to do two-way communication via WebSockets. Not two-way communication, more like a request-response model kind of a communication. This is a very common pattern. You will see this use case many times. If you've ever created WebRTC servers, there is something called the offer and the, oh God, I'm so old. Offer, and you create an offer, you get back a, let's say, response. It's called something else, I'm forgetting now. But in WebRTC also, whenever you want to communicate or create a WebRTC connection between two machines, make them send video to each other, the first side creates an offer, the second side responds back with an answer. I remember now. So udhar bhi aisa hota hai ki you need some sort of a request response model. I'm sending the offer, I want a answer. Same thing is happening here. This guy wants to initiate a message. For sure, it wants to send a message to the other side. But it also wants that whenever the other side responds, this function gets called. That is happening via this global callbacks array. So to recap, we needed two-way communication between the validator and the hub. The validator can initiate requests and expect a response. The hub can initiate requests and expect a response. Both the validator and the hub maintain a global callbacks array. every entry over here is a pending request sent to the other side. Every entry on this global object is a request has been sent to the other side. It hasn't yet responded. As soon as it responds, we call that entry, we call that specific function, and we delete this entry from the row as well. We delete this from this specific global callback array. We don't need it anymore. We just need to call it once. So this is how both the sides are maintaining a request response cycle. Anything you see in this global callback array is a pending request sent to the other side. Whenever the other side responds, that specific function will get called. It will do its thing. In case of the hub, it will be storing something in the database. In case of the validator, it will be storing some global variables we'll see. But that is, how we have created this request response model in WebSockets. That's the first hard thing to do. Again, this is done already. If you remember, a while back, I added facebook.com in front of you. Now you can see so many ticks are already there. It already has, been propagating for the last 25 minutes, and, slowly the full 30 minutes will get propagated. If I turn off my internet, or, whatever, facebook.com goes down, you will actually see red marks over here. You'll see uptime go down. You'll see this become red as well, similar to this guy. So it's already happening. The code is written. I'm just trying my best to make it easy to digest the code because it's a little hard, specifically the architecture that we've written over here. Okay? That's the first difficult thing. Callback based communication. We're coming to its implementation very soon. One more difficult thing, and this is around authentication using not Google, not login with Google, not login with Facebook, not login with email, but login with Solana wallets. The thing about validators, what are we building? We're building a decentralized physical infrastructure network on Solana. These validator they want to evade taxes. They don't want to give taxes. They are random people that don't want money in their internet. They want money on, their crypto wallet. So they will not give their bank account information to the hub. They are saying, I'm giving you services. I am a validator. I am validating requests or websites from time to time. I want to get paid in crypto. So when the validator signs up, right? You remember the sign up request? Whenever the validator is signing up, do you remember I said they will send their Solana address to the other side? I also said bank address, but as I said, bank addresses are really bad for micro transactions. Here, there might be $5 transactions, $2 transactions. If I validate for 3 days, I might only make $7. So Solana is a decent use case for that because you can get micro transactions from anywhere around the world without a remittance fee, without a transaction fee, without a 2-day delay, so on and so forth. So the validator, when it signs up, if you remember the schema as well, if you remember the schema, the validator maybe had this field called the public key, which is their Solana public address. If you look at my backpack wallet here, you will see I have a public key, an address I can share with the world, an address that the world can see my balances on, and also send me money. The validator wants the same thing. They want, you should send me money whenever I validated 100 requests. You should send me money to my Solana wallet. So I can see it over here. I can see, whatever, 10 USDT or 20 USDT or whatever. Let's say I have 3,700 USDT. The validator also wants to receive this money from the hub. The hub will receive it from its end users. The end users will pay the hub to, do its thing. I'm really low. So the question is, how does the validator tell the hub, I am indeed owner of this public key? How does abhi tak, when we were sending requests to a backend, if I'm sending requests from here to a backend, I am actually sending an authentication header to the backend, right? If I refresh this, and if you look at the /websites request headers, you see a authorization header over here, which has a very long token. That's how I identify myself to the server. That's how I tell the server I am 𝗁𝗁𝗏 or I am Raman or I am someone else. Clerk gives us this JWT. But these people don't have an email address. They are not logging in with Google. They just have a Solana wallet. What is a Solana wallet? It is a public-private key pair. Repeat with me, what is a Solana wallet? I have some money over here. You saw $3,700. How do I get access to these? How do I pay using my electricity bills using this? Using my public-private key pair. What is my public key? Everyone can see this is my public key. What is my private key? I will not show you, but I can export my private key from here somehow. For people who know Solana, know this. For people who know crypto generally, they know this. Private key is something that is enough for you to pull out funds from a wallet. So my private key is with me. Validator will have its own private key. They will keep it with themselves. And whenever they are sending a message to the hub, I want to sign up, or yeah, I have validated this request. Google.com is returning a 200 status code. We need them to sign a message. We need them to do what? We need them to sign a message. We need them to send a signature along with the request. Request to bhejoge hi. You will send the request. You will send the callback ID. These two things you will send. The third thing you are sending is the signature. What is a signature? So here is something interesting about this public key, private key that I'm talking about. If you've gone through general public private key algorithms, if you understand hashing, cryptography, a very common example of this is that whenever you have a private key like this, right? Private key kya hai? Something I need to keep private. Public key kya hai? Something I can tell to the world. So if it is a very weird example, but one that's easy to understand. Let's say this is Osama bin Laden. This is Osama bin Laden, and he wants to tell the world that, hey, I am preparing for an attack at XYZ place. How will he tell it? Should he come on the internet, on the television, and tell everyone, hey, I am Osama, I want to attack the network, I'm going to attack this specific building? Sure, but who knows if it's true or not? It might be, okay, it's a deep fake video or whatever. So assuming this is not the way, how will he communicate to the world he wants to attack? What he could do is, he could create a public-private key pair. These are very easy to create. Like you can create one for yourself very quickly. I'll show you how. He could create a public-private key pair. And only one time, he needs to tell the world that this is my public key. He needs to broadcast this on TV or someplace else, like blow up a building and tell everyone, okay, hey, this is my public key, remember this. So now everyone knows Osama's public key. Just like if I currently open this wallet, and copy this public key and show it to you, which I can. There's nothing wrong here. You can just track my wallet and see how much money I have. But if I share it with you, everyone knows my public key then. Everyone knows sort of my bank account number. So he has shared his public key with everyone. Now, whenever he wants to send a message to the world, whenever he wants to send a message like, I will attack XYZ on 23rd December, let's say. Whenever he wants to send this message, he can sign the message using his private key. What will he do? He has his private key on his laptop, right? So he will use his private key, sign the message, that will convert this into some random gibberish that he can share with the world. What can he do? He will share this gibberish with the world. He will tell the world, hey, here is my original message. Here is my signature. You can verify using my public key that this signature is indeed correct. And hence this message came from Osama. Everyone knows Osama's public key is this. Osama came on television or some random news came. This message was signed by Osama. This is the original message. This is the signed message. So anyone in the world can take this, use Osama's public key and decode that indeed this is true. The signature is valid for this specific message without having Osama's private key. Private key is only with Osama. Osama used it to sign the message. The world is using it to verify the message. What does this verification mean? It means that only Osama could have done this. No one else, unless they have Osama's private key, can sign this message like this. Only someone who has the private key that Osama has, the corresponding private key to Osama's public key, can sign this message and create this gibberish. So that is where the panic should hit, and people should understand that this message indeed came from Osama without him having to come on television also. As long as this message is broadcasted, people can verify that indeed it came from Osama's public key. Why am I giving such a weird analogy? Because we have to do something similar. Whenever the validator is sending a message, we don't have authorization headers. We have not logged in with Google. We are just telling the other side that this is my public key. This is where you need to pay me. So we need to tell the other side, okay, here is a signature that validates that this is indeed me. I have a public-private key pair, my Solana public-private key pair, the one where I'll receive balances, and this private key I will use to spend money on electricity bills, let's say. So when I'm sending a message, I send the original payload. I want to sign up with this public key. I send the callback ID. Whatever response comes back, I have a place where the callback function is present using this. And I give a signature, which basically means I sign some sort of a message. Okay, I am sending you request to sign up. I sign this message, which means convert this message to some gibberish so that the hub can verify that this message indeed came from the validator who has this public key. Otherwise, some random person can come and send a request, I am validator XYZ, and this is the response that I got back, right? We don't want that. We want validator should be able to authenticate with the hub, and we don't have login with Google, login with Facebook. We have login with public keys. So this is the standard way to log into any website. For example, let me show you. If I go to tensor.trade and give myself anxiety by tracking the price of an NFT I own a lot. Pretty stable. So here, when I connect the wallet, you'll notice it lets me connect wallet immediately. If I click on connect wallet, my wallet is connected. But if I want to see something private like my rewards, it says authenticate yourself. It says you have not logged in with Google, not logged in with Facebook, you have logged in with a random wallet here. So पहले खुद को authenticate करो. What does it say? Authenticate to see your rewards. Only you can see your linked wallet, verify wallet. When I click on verify wallet, you will see it asks Backpack to sign a message. You don't see that message here very well. If I was using Phantom, you would have seen it. But this is me signing a specific message. This is me signing a message like login to Tensor. There you go, something like this. Authenticate wallet this by signing below a random ID. So if I click on approve, I'll actually sign this message using my public key to tell Tensor ka backend that this is me, 𝗠𝘁𝗲𝗏. Same thing as we want. What do we want? When the validator is signing up or sending any request, they should sign a message that says something similar to what Tensor said. What was Tensor saying? Authenticate to tensor.com. What are we saying? I am sending you a request to sign up. I am sending you a request to respond back to a validate request. All of these messages should be signed by the validator. What does signing a message mean? Just calling a function on, using this private key, private key dot sign, let's say. And the message could be whatever. I am sending you request to sign up. Something like this. Simple. Architecture thoda samajh aaya. Two things we learned. Public private key pairs in Solana. How can you sign a message and verify on the other side? Other thing we learned. Normal WebSocket connection between two servers with a callback based architecture where if this guy wants to request and wants a specific callback to be called, whenever the response comes back, we can use this callback based architecture where there is a global callbacks array. And the callbacks array represents the current pending requests that have been sent, but that haven't yet responded. As soon as the other side responds, we call this function and we delete that specific value from the global callbacks array. That's how we have maintained a request response model between the validator and the hub. Now let's look at the code. The code isn't too many lines of code. It's just, if you look at the validator, it's around 97 lines of code. If you look at the hub, it's around 163 lines of code. So I'll take you through both of these code bases next. I would urge you to code them yourself. I coded them myself, took me around 3 hours. I have that video as well, but that's all over the place as we are figuring things out. So this is a much more contained version of what I learned over the last 3 hours. Let's get into the code base next. All right, let's look at all the code changes I have made next. First thing I've done is, if you look at the schema, for every validator, I've added a new field called pending payouts, which means how much money we owe them, how much validation they have done. Let's say they might have done validation for 10 days. So slowly this number will increase to 0.1 SOL or 1 SOL or 2 SOL based on how much validation they have done, or 10 USDC, 20 USDC. And eventually we need to pay them out based on this number. Our database has a hard-coded, not a hard-coded number, but a centralized number, which is their balance, similar to your Paytm wallet balance or your Cash App wallet balance. We will slowly increase this number based on how many validations they are doing. That's the only thing I've changed in the schema. The database has changed a little bit. The pending payouts field has been added. Eventually, we will use this to pay them out in Solana. 2 more files I've added. One is apps/hub/index.ts. So this has all the hubs ka code. Let's look at the code that I've written over here. It's in the end at the high level, 1, 2, 3, 4 high level functions that I've added. and a bunch of global variables. So let's start from the global variables and imports. I've imported random UUID v7 from bun because I want to generate random IDs. Callback IDs are going to be random. This function gives me a random ID. That's why I've imported it. You can write your own random ID generation function as well. A bunch of types. I've created a new package called common. I've created a new package called common, inside which I've introduced a bunch of types called, the two high level ones are incoming message and outgoing message. These are the incoming messages to the WebSocket server. These are the outgoing messages from the WebSocket server. So what all incoming messages will be there on the WebSocket server? If you remember, what all will the user send us? The validator send us. If I command Z it a few times, damn a lot of code, huh? Basically, it was the sign up message, right? Whenever the validator comes up, it sends us a sign up message telling the hub, ki, hey, I'm ready. Please send me messages. So one message that the hub will receive would be a sign up message, and the other message it will receive would be a response message, to the validate request that the hub initiated. So the two incoming messages here are a sign up message and a validate response. So that is what I've defined clearly in a type called incoming messages, a sign up request and a validate request. And what are the outgoing messages from the WebSocket server? Again, a sign up and a validate request, right? I am responding back to a sign up request. I am initiating a validate request. So we have two messages right now at a high level, one initiated by the validator, one initiated by the hub. The validator initiated message will get a response. The hub initiated message will also get back a response, which is why these are the sort of two types at a high level that I've introduced. When I get a incoming message for signing up, when the validator tells me, okay, I want to sign up, what all data will it send me? What data will it send me? Sign up outgoing message. This is another type I've introduced. Sign up incoming message, WebSocket server mein incoming message. What is this type? It says the validator will tell me its IP, its public key, the signed message. Do you remember the signed message? The validator, whenever it's sending me some data, it will sign a message and send it to me across so I can authenticate that this is indeed coming from that validator, and a callback ID. Do you remember these were the four things we added here? What were the four things that were present here? The sign up type, the name of the validator, we don't have the name, but the IP, the domain, things like these. Their Solana address, their public key, their location IP, and what are the two extra things I told? The callback ID and the signature. Let me just add it here. The signature. For any request that's coming to the hub, there needs to be a signature. The validator needs to sign the message. The validator needs to authenticate with the hub, which is why all the incoming messages, the sign up incoming message and the validate incoming message, have a signed message that we expect from the validator. All the outgoing messages, whenever I'm responding back on the sign up request, I just return them their validator ID and their callback ID. Okay, you sent me a request a while back. Here is the callback ID and here is the validator ID that I've created in my database for you. And when I'm sending it a request, when I'm initiating a request, whenever I'm sending this second request to validate, I'm sending a URL, the URL that the validator needs to send a request to get the response back from, my own callback ID. We don't really need the website ID, I think, but chalo, we send it the website ID as well, which is our database ID for that website. Whenever I go here and create a new website, each one of these has a database ID, right? That database ID also I forward to the validator. That's the outgoing messages. Sign up outgoing message, validator outgoing message. These are the incoming messages to the WebSocket server. That's how I've named it. Incoming message means any message that's coming to the WebSocket server. Outgoing message means any message that's going out from the WebSocket server. This one gets initiated from the validator. This one gets initiated from the WebSocket server. This is a response from the hub. This is the response from the validator. Simple. 4 types. It's just type safety. That's it. Like we don't really need this file, but since we're using TypeScript, we need common types in both the places. I've defined them in a common package called packages/common, where I've defined all of these types. That is the thing that's present here at the top. The incoming messages and the incoming message, which is this thing right here, and the sign up incoming message, which is this. We just need these two types over here on the hub. Prisma client import. Now here comes some Solana specific imports. Public key is an export that comes from @solana/web3.js. So if you've done client side Solana, if you've dealt with client side Ethereum also, you might have heard of web3.js. @solana/web3.js gives you a bunch of classes, functions for dealing with signing messages, verifying messages. That's why we need public key over here. The same is true for both of these libraries, NaCl and NaCl utils. We will use whenever we are verifying messages from a signature, whenever we are signing a message. So these three imports at the end are just for signature verification from the other side. We have a global array called available validators. Whenever a validator signs up with us, we push them over here. Whenever a validator dies or kills itself, we remove them from here. Callbacks. Do we remember the global callbacks array? A callback ID and a corresponding function. If you look at the signature of the function, the signature is the callback function will be called with the data that has type incoming message. The callback function will be called with types that look like this, incoming message, because जब भी घूम के data आएगा, वैसे तो घूम के only this will come. We can restrict its type even further. But अभी के लिए we have said any incoming message is what will be eventually passed in as an argument here to the incoming message callback. Do we remember this? Do we remember this code that we wrote a while back? What did we say? Ki callbacks of callback IDs function status, which is something the other guy returns. What was the other guy returning? Status good callback ID something. This is what this function is eventually called with, right? And hence callbacks array ka type kya hai? The type is the argument that's eventually going to come here is the incoming message from the other side, which, in this case had just the status. In our case also we'll have the status, the latency, the callback ID, things like these. Cost per validation. How much money should we increase in the database for every validation that the end user does? So I've written 100 over here. That's not 100 rupees. That's 100 lampposts. That is nothing but 0.000001 sol. What entry am I putting in the database? The unit of the entry is lampposts. If this was rupees, I would put it in not INR but paise. I will never put 0.01 rupees in the database. Database should never have floating point numbers for money that you owe someone. If you're building something like Razorpay, or if you have interacted with Razorpay APIs, if someone pays you 50 rupees, what you get back in Razorpay is this, 5,000. Even though they've paid you 50 rupees, you get 5,000. Why? Because you never store floating point numbers in a database, especially if that's money that you're storing. Because there is something called precision errors in computers. Computers may, if you try to store 50, it might store this, or it might store this. You want to store 50, but floating point numbers mean there is only so much math you can do. There is only so much precision you can store it with. But integers are stored with precision. So if you owe someone 51.11 rupees, in the database you should store this. You should never store 51.11. You should never store floating point numbers in a database, especially if that's money that you owe other people. So what have we written? A cost per validation is 100 lampposts, which means 0.000001 Solana every user will get, or every validator will get for every validation that they do. Then comes the web1.serve, which is nothing but an HTTP, how you create an HTTP server in Bun. Harkirat, why not use Express? You can use Express. Harkirat, why are we using HTTP? We don't want to use WebSockets. Because WebSockets also under the hood use HTTP only. A WebSocket request is nothing but an HTTP request that is eventually upgraded. So this is just the standard way to do WebSockets in Bun. If you want to Google, you can Google Bun WebSockets and it will give you its starter sort of code for a WebSocket server. It looks something like this. Bun.serve. Whenever a HTTP request comes, upgrade the request. What does server.upgrade do? It upgrades the request to a WebSocket request. And then you have a bunch of handlers that you can add over here for incoming messages and outgoing messages. So what does this line of code do? If server.upgrade request happens, if the request upgrade can happen, if the user is on a new browser that supports WebSockets, if the user is on a a server which supports WebSockets, then this will succeed. Their request will be updated to upgraded to a WebSocket request. But if that doesn't happen, we tell them upgrade failed. So this is common practice you should do. And sometimes, frameworks like Socket.io fall back to HTTP WebSocket. The browser doesn't support WebSockets, but most browsers today support WebSockets. So, this shouldn't be a problem. Control will reach here. This will return true. It will get returned over here. Then inside the WebSockets callbacks, you have, 4 callbacks. Message, which means whenever a message comes from the other side. Open, which means the socket has just opened and someone has initiated a request with you. Close, as you can guess, whenever the request closes, the browser closes or the server closes that's connected to you, the close callback will get called. And drain, the socket is ready to receive more data. So drain is a callback that gets called when the socket can receive more data. A lot of times the socket might be blocked. You might have 100 pending requests, in which case, when those get cleared, the drain function will get, or the drain callback will get called. These are the 4 callbacks we have access to. Which one do we need? We only need the message callback. We can use the open callback as well. We definitely need the close callback also. Okay, when the validator closes a request, we want to remove them from our global available validators array. So if you look at the WebSocket callbacks, I'm using the close callback. Close callback is simple. Whenever a validator closes their connection with me, they die, their server dies, they don't want to validate with us anymore, they're not getting paid enough. So we just remove them from this global available validators object, which means we're not going to forward them any more requests. That's what this line of code does. Just Google what splice does. It lets you remove an entry from an array. The message callback is the interesting one. Okay, the other side gave you a message. The validator is sending you a message. It is either of type sign up. What does sign up mean? Okay, they want to sign up with us. They want to start validating with us. So what do? We first verify their signature. What does verify message over here do? Verify message, if you look at the function body, we'll look at it very soon, verifies कि उन्होंने जो signature भेजा है, the signature that they have sent, is it valid for their public key? Do you remember the Osama bin Laden example? Whenever Osama broadcasts a message, we can use his public key to verify that indeed they have signed this message. And what is the other side signing? The other side is signing signed message for callback ID, public key. This guy is initiating a message. The sign up message is initiated by the validator, but they also send us a signature. Which is them signing the text that looks like this. I have signed a message for callback ID, public key. So ये जो callback ID, this callback ID and this public key or Solana address, these two things we have sort of put in the final message that they are signing. The final message that they are signing contains some English text and this callback ID right here. So that signature is what came to the hub. The hub is verifying, is this signature valid? It's similar to you authenticating from Clerk or authenticating from a JWT. That is what this function does. If it is verified, if they have sent us the right message, then we call the sign up handler, which is this function right here. Where what do? When the user signs up, we first check does this validator already exist? Has someone in the past given us this public key, given us this Solana address and validated with us? If yes, then we just tell them, hey, sign up request has succeeded. You are an available validator now. This is your validator ID. And of course, we return them their callback ID. They gave us a callback ID. We return them back their callback ID. So on their side, they know what function to call. And we push them to the available validators. So global array tha, this global array of available validators now contains them as well. If they are not signed up with us, if this is the first time they're signing up, then we will put an entry in the database. A new validator has been created. Ideally, we should pull their IP from their request. Ideally, we should pull their location from their IP. We can hit, an API that gives us a location given an IP so that we know where they're validating from. Is it from Delhi? Is it from Bombay? Is it from Africa? And we can eventually distribute traffic across the world. Abhikli, I have not done that, but here is a to-do. Given the IP, return their location. And then we send them back, hey, sign up has happened. You can now expect to receive requests from us. This is your validator ID. And we push them to the validators array, the available validators array. So when someone sends us a sign up message, we first verify, Have they signed the message correctly with their public key? And if they have, we put an entry in the database, we let them know their validator ID, and we store them in this global available validators array. Slowly, this available validators array will start to get populated. It will have 100 validators, 1,000 validators, people who want to validate with us, people who want to earn money by, whatever, taking care of their or using their decentralized physical infrastructure network. The second callback is if data.type is validate. If it is validate, that means I had initiated a request. Hub initiates the validate request. You just get back a response. The hub initiates a request every 3 minutes, tells various validators to do something. And when we get back type validate, just means we need to call a callback. Do you remember this? What did we write over here? We said, okay, when we want to send request, we will create this callbacks array. And when we get back a response, we will simply call that callback function. That is the same thing that's happening here. We are simply calling that function with that callback ID. We are deleting that from the global callbacks array. Simple. Question is, where do we initiate the validate request? Where do we initiate this validate request? Where have we written the logic? Okay, every 3 minutes, we need to send some data to the validator. The validator needs to respond back. So that is where this last thing comes into the picture. A set interval, which is running for now every minute, but we can increase or decrease it. Let's look through the logic of the set interval. What function is it calling every 1 minute? It's getting all the websites that we have to monitor from the database. Prisma client.website.find many, where disabled is false. Any website that's not been deleted by the user, we get it. And for each one of those websites, I send a request to every validator. So we should change this logic. We should distribute traffic across validators. We shouldn't send every validator every website. We should send the first website to 20 validators in different regions, second website to 20 validators in different regions. We should distribute them. Abhi ke liye, the logic simply says, for every website that exists in our database, which could be thousands, send a request to every validator, which could be a lot, like 1,000 into 1,000 is a very big number, right? So this logic should change. If we have a lot of validators, we should distribute traffic amongst them. Every validator should not receive requests to validate every website. Fair? Cool. So for every website and for every available validator, so it's just like a for loop inside a for loop, an n square for loop or n into m for loop. We first generate a random callback ID. कि यार ये मैं request तो भेज रहा हूँ. I am sending this request. I first have to generate the random ID. That happens here. I log something. I do a validator.socket.send. So for every validator, I am sending them a message that looks like this. Type validate data. This is the URL you need to validate, and this is the callback ID. Did we discuss this only a while back? What are we sending to the other side? A callback ID, the website they should validate, and the type of the message which is validate. Same thing I'm sending here. Type of the message is validate. URL is the URL of that website that exists in our database, and a randomly generated ID. What is the next thing we have to do? What was the next thing we did over here? We send the user this and we made an entry in the global callbacks array, because eventually वो message घूम के आएगा. When the message comes back, we want this function to get called. We say callbacks of callback ID is this very big function. What is the function doing? It's checking if the data.type is validate, which it will be. We don't need this if check. It's just for TypeScript. It's a good idea to add this if check. But this function will get called with a validate message only. When we get this, we extract the data that the other side returned us. We extract the data that the other side returned us. What will it return us? Whether or not this was a successful request to google.com, how much time did it take to hit google.com, callback ID and the signature. It will still return me the signature. Every request that I'm sending to the validator should respond back with a signature. We need to ensure this is the same validator responding back and not some random person. So validator ID, status, good or bad, latency, how long did it take for them to hit google.com, and the signed message. We first verify the message. If it is not verified, if they have not signed it correctly, we return right then and there. If they have, then it's simple, right? Just put an entry in the ticks table. Increase the validator's balance by a little bit. What does this do? This is a transaction, which means either both of these will go in the database or none of them will. If by mistake this request fails or this request fails, then the other request will also revert. That is what a transaction does. Why do we need it here? Because only if their validation has reached our database, do we want to pay them money. What is this doing? Transaction.validator.update, where validator ID is this. Increase the pending payout by cost per validation. Give them some extra Solana in the centralized database. Not yet sending them Solana, increasing their balance in the centralized database. And here, what are we doing? Transaction.website_tick.create. We're creating a new tick in the database with this data. Okay, for this website ID, this validator ID has made an entry. This is the status that validator got. This is the latency that validator got. And this is when this entry was created. So this is where, it ends. This is where we're able to store the tick in the database. We're able to update the balance of the user by a little bit. Okay? So that's the hub. What is the hub doing to recap? The hub has 4 parts or 4 functions. The basic WebSocket handler, a sign up handler. Whenever the user signs up, this function gets called. A set interval that is constantly every 1 minute getting called and distributing traffic to various validators. And the last function we haven't looked at is verify message. Verify message is again a Solana specific function, not a Solana specific function, like a public private key pair specific function. What is it doing? Where does it get called? It gets called whenever we receive a signature from the other side. Whenever the other side sends us a message, we first verify and make sure indeed this message was signed by them. So this is the text of the body. This is the public key. This is the public key of the corresponding private key they signed the message with. And this is their signed message, which could be some gibberish. We send this as the arguments to verify message. What does verify message do? It first converts their text message, not their text message, the message that the original message that they have signed over to a bunch of bytes, which means zeros and ones, not zeros and ones. Bytes are a little bit more, you get the idea, right? Bits are zeros, one, bytes are anything from 0 to 255. It converts them to a bunch of bytes. We call nacl.sign.detach.verify. This is the function that takes the original message bytes as an input. It takes the signature, also converted to a bunch of bytes as input, and the public key as the input, and checks, okay, was this message signature valid for this original message for this specific public key? This is what we were saying. If Osama broadcasts a message that's signed, we can use their signed message, their original message, and their public key to verify, has this message been signed by Osama or not? And we return result over here, which will be true or false based on if the signature is correct. That is what the verify message function does. It gets called here also when the user signs up. It gets called here also when the user, when the validator responds back to a message. Then also we first verify their message. Only if it's verified do we store the entry in the database. And once the entry is stored in the database, the front end can just refresh and get the newer ticks. So that's how we're doing the hub. Hopefully that's simple enough. 4 sections: the WebSocket handler, the sign up handler, the verify message function, and the interval that's getting called every 1 minute right now, but we can change this interval, and distributing traffic to various validators. For now, every website is reaching every validator. We should write some logic to distribute, every website to at max 10 validators and distribute it equally. So every validator gets, enough websites to verify. That's the hub ka code. Can you imagine what the other side would look? The validator would look. It would not create a WebSocket server. It would create a WebSocket client. And it would not verify a message. It would sign a message. Everything else will be the same. There will be a global callbacks array, which will contain all the pending requests. But rather than creating a WebSocket server, we initiate a WebSocket client. Rather than verifying a message, we sign a message. So let's look at the validator code next. All right, let's look at the validator next. It has a global function called main, which we call once. As you can see over here, we have a random interval at the end. There are better ways of doing it, but we need this to be a constantly running application, constantly connected to a WebSocket server, listening for messages, responding back. Hence, I have just added a random set interval at the end so that this continues for a long time. I have 3 functions in the end. The main function that will initiate the WebSocket connection, get the response from the other side, messages from the other side. Whenever one of the messages is the validate message, the validate handler gets called. And a function called sign message, which is the equivalent of verify message on the other side. What does sign message over here do? It converts the message into bytes. It calls nacl.sign.detached these message bytes and this private key. What is this key pair dot private key? It's the private key of my Solana wallet. The validator can have that on their server, right? This code will eventually run on the validator server where they might or need to, in this case, have their Solana private key as well. They will use to sign the message, and then we just return the message from here. So this function takes a message as an input, which could be, whatever message we expect to send on the other side, signs the message and returns the message. The message over here is again an array of bytes, and what we're doing over here is converting those array of bytes to a string. On the other side, we convert that string over to an array of bytes. If you remember, on the other side, when we call verify message, we convert the signature into an array of bytes by first parsing the signature, which was stringified on the other side. Here it is stringified. Here it is parsed. And then we convert it into a uint8 array, which is an array of bits or bytes. Sorry. Cool. So that's the sign message function. We'll see where this is called. Let's get to the main function. What is it doing? The first thing it's doing is keyPair.from secret key uint8 array.from json.parse process.env.private key. So my Solana private key, as I said, I can go over here and export it. I of course don't want to do that and show it to you guys. But whenever you generate a Solana wallet from here, you can export its private key. You can export it as a string, or you can export it as a bunch of bytes. In my case, I've exported it as a bunch of bytes and stored it in this env file. So this private key that you see over here, which is byte number 1, byte number 2, byte number 3, byte number 4, is a private key to my Solana wallet. This private key I'm using to sign the messages and send the messages on the other side. This is the wallet where I will eventually receive Solana whenever I get paid. So that's what this env file exports. I get the value over here. I convert it into a key pair. What is a key pair? Again, it comes from @solana/web3.js. It gives you constructs like public key, private key, verify a message, sign a message, send a transaction, things like these. So the key pair object over here is what I convert this private key into. And this key pair object, we will see eventually where it is used to, use the public key, use the private key. I create a WebSocket connection to the hub. Currently, the hub is hosted on localhost 8081. Eventually, it will be at hub.betteruptime.com. Whenever I receive a message, there will be two types of messages. The sign up message will now be a response. The validator initiates the sign up message. The other guy responds back. So what do I have to do? I simply have to call the callback over here. Where is this callback defined? We'll see eventually. But when I receive the message, I just have to call the callback, which is the same thing that was happening in the hub for the other message. On the hub, whenever the validate message was received, I was calling the callback. On the validator, whenever the sign up message is received, I will call the callback, because these are the messages that I initiated. I have just gotten a response from the other side. The validate message, if I get, that means the hub is telling me to validate a specific website. We call the validate handler. And what does the validate handler do? The validate handler is, we log validating the specific URL. We start tracking the time. We get the signature. We sign the message that says replying to callback ID with the key pair. What do we do over here? We call the sign message function we saw a while back. And this is the message that we're signing right now. Okay, I'm replying to this callback. If you look at the other side in the validator, in the hub, that is exactly the message we verify over here. If you remember, in the set interval that I have, what message do I verify? I verify replying to callback ID. This is this is me verifying the message. This is the validator signing the message. So it signs this message. You can decide the schema of this message. Could be more complicated. I've kept it very simple. Then comes the real meat of the logic. Us hitting that specific website, google.com, facebook.com, getting how much time it took. This is when I started the request. This is when I ended the request. This is the net time that it took for the request to go out. The status, was it a 200 status code? Was it a 404 status code? Is the website up? Is the website down? And then we respond back to the other side. We send them a validate response with this data. Here, for your callback ID that you had sent me, this is the status, could be good or bad. This is the latency. This is the website ID that you sent me. This is the validator ID, who am I? And this is a signed message that you can verify with and ensure that this message indeed came from me. If this request fails, then we send a bad response to the other side. Here, I tried to hit it, but there was something wrong. The server is down. I got a 400, and hence the catch Control reached here and I send back a bad request or a bad response to the hub. Okay, this specific website is down right now. Latency I've hard-coded to 1000, doesn't really matter. Will not be used for bad requests. The next question is, where do I initiate the sign up request? And as you would imagine, after the WebSocket connection opens, here's me initiating the WebSocket connection. Here is what happens when I receive a message from the other side. But when the WebSocket connection opens is when I generate a random callback ID. We push to the callback a very simple function that stores the validator ID in the global variable. We have a global variable called validator ID. We sign a message that says signed message for callback ID public key using the key pair. And we send the sign up message to the other side. IP I have hard coded for now. We should change this. This should be the actual server IP. If it's in Africa, it should be the Africa server IP. We shouldn't really expect the user to give this to us. We should extract this directly from their request, but to be clear, this is fine. Their public key and the signed message. So this sign up message they send us over here whenever they connect to us. We receive it over here in the hub. Where do we receive it? We receive it in the hub over here. We check is this a right message, and if it is, we call the sign up handler, which stores their entry in the database, responds back with the validator ID, which they get back in this callback and store it over here. So can you see the chronology of events that is happening? I am sending a WebSocket message here. It is getting received over here. It is calling the sign up handler, which is responding back with the message, which is leading the control to eventually reach here, because that control will come here. Whenever the other side responds to the sign up message, control will reach here. I will call callbacks of callback ID, which will call this function right here and set the validator ID. Simple. That's how the two-way communication is happening for the sign up message. And how is it happening for the other message? In this interval, I am going over all the websites. These are the websites I have to monitor. For every website and for every validator, I am telling the validator to validate. I'm giving them a callback ID. And then I'm defining this function. I'm not yet calling this function, I'm defining this function. This message reached the other side. Where this message reached the other side? Over here. We call the validate handler. What is the validate handler doing? The thing it is supposed to do. Generate the signature, send a request to that specific website, calculate the time it took, and respond back. When it responds back with type validate, what happens? Control reaches here. What do we call here? We simply call the callback. We simply call the callback with the data that came from the other side, which means we simply call this callback right here. What is it doing? If data type is validate, then do something, which is, whatever, store the tick in the database. First verify the message, then store the tick in the database and give the user some more balance, whatever, they might have earned for verifying / validating this specific request. Is this clear? Do we understand how the hub and the validator are working? Let's see it in action. Let's look at a quick demo. The front end, let me restart. The backend, let me start. The hub, let me start. And the validator, let me start as well. So now the validator is hopefully connected to the hub. We should add some more logs to see that. What websites do I have currently? I have at least one user of mine that's currently logged in, this 𝗁𝗁𝗿𝗀𝗃 user. They have 1, 2, 3, 4, excuse me, 5 websites. The validator was down, if you remember, and hence, everything is gray. For the last 30 minutes, nothing was tracked because all the validators were down, the hub was also down. Now the hub is up, the validators are up. Slowly, we will see all these ticks getting populated. Let me add another website, twitter.com. Now I have, a bunch of these websites that I'm hoping get tracked in a decentralized fashion by many validators all around the world. But only after a minute, when the requests reach the validator, will we see these get populated. So let's look at the logs. If you remember, we do have very simple logs. Whenever we send the validate request, which will happen every 1 minute. Every 1 minute, we'll send the validate request to all the validators. Currently, I only have one validator. As you can see, the hub sent validate request for google.com, test.com, google.com, ASD. These are all the websites that currently exist for various users. 2 users can validate the same URL as well. 2 users might have google.com, 2 users might have test.com. A single user might also put multiple values. We can add those checks to fix that. I sent these validate requests to all the validators. Currently, we only have one validator, and notice it was able to correctly validate these. ASDSD is a wrong URL, which is why it reached the catch section of the try catch block. Same is true for, test.com. Test.com doesn't have a certificate, which is why HTTPS is failing over there. So these two requests fail. That is why, this and twitter.com also failed for some reason. We'll see why. I would have expected, it's probably because it did not give, it redirected to x.com. So it did not give a status code of 200, it gave a different status code. But let me add x.com here as well. And then we'll see that does x.com give us the right URL. And twitter.com is sort of down because of our code logic. In the validator /index.js, we sort of just check the status code to be 200. What twitter.com returns is a status code of 301, which means redirect. That is why, bad gets registered as the status code. So we can change that logic over here. All right, let's do another end-to-end test. We have a website that looks like this. User can come and sign in or sign up. Once they open it, log in with their email. Eventually, all of this would go away. It will not say development mode when we deploy this to prod. They can log in using an email. They can open the dashboard. They see no websites right now. They can add websites, for example, google.com. $100xdevs.com and x.com. All three of these are valid websites. Generally, the thing that's tracked are backend endpoints, and over there also some specific health check endpoints. So, x.com/health check or api.100xdevs.com/health check. Once you do this, initially you see gray because your tracking hasn't yet started. After 10 minutes, if you see, some of these ticks will start to propagate, and you'll see, the greens or the reds based on whether or not this specific website is up. Good things to add would be monitoring, calling, emails, sending out notifications or alerts whenever your website goes down, something we can add eventually. And as validators are validating your requests, they're getting not paid yet, they're seeing a balance. So a validator can, firstly, as you can see, a few ticks came. Green here and x.com is red. Why is x.com red, 𝗁𝗁𝗏? I had the same question. And the answer is because x.com only supports specific browsers. If you try to send it a request via a Node.js backend or terminal or even Postman, this is the response that you get back. This browser is no longer supported and 400 bad requests. So if the folks at x.com want to use our platform, they will need to expose a health check endpoint that works for everyone, like even for old browsers, new browsers, Postman, or a terminal, so that we can actually actively track the requests or their website. Currently, that cannot happen because their landing page will block all requests coming from our validators. Cool. After a few minutes, you'll see all of these get populated. While this is happening, our validators are getting not exactly paid, but their balances are increasing in the database. So let me keep this up only. But if I open the database really quickly, so docker ps, docker exec, psql, select star from validator. I have a bunch of validators. The last one has, as you can see, 93100 as the balance. This is their pending payout. That's equivalent to some 0.0000931 Solana. The next endpoint we need to expose is an endpoint that the users can hit and actually get paid. If the validator wants to get paid, they should be able to hit an endpoint with their public key and be able to receive their payouts. There are two ways of doing this, like the easy approach that's vulnerable and the harder approach that's a little easy. That's not easy, but covers all corners and is the withdrawal approach you would use if you're creating an exchange, a website like stake.com, where you want to have withdrawals on your website, allowing people to withdraw crypto directly to their wallets. The easy approach is as simple as go to your primary backend, api/index.ts, introduce an endpoint here, /api/v1/payout/ let's say public key. that anyone can call really, doesn't matter. You can authenticate it if need be, okay, only the validator can call them, add signature verification here, it doesn't really matter, right? Anyone calls this, that specific validator gets paid. So get the user's public key and decrease their payout. So Prisma client dot validator dot update, where public key is this, set their pending payout to be 0. Also, we should get their current pending payout, how much money we owe them. So const validator equal to this. If not validator, return status code of 400. Update the validator to have a pending payout of 0. And where public is this thing? Why is there a problem here? We need to add uniqueness constraint to the public key. What we can do is we can just change this to the validator ID. So that way, whenever a validator wants to, get paid, they can hit this endpoint. Where validator is this, and where validator ID is this. We can set the pending payout to 0. And here we need to send a transaction to Solana to pay them out. If you've ever done this, a very simple transaction, we will need to introduce Solana/web3.js here. We'll have to create a connection to an RPC, and then we have to write some code, like 3 lines of code. But is this enough? Like, I can write this and start my website and hope for the best to happen. But what problem will you see over here? If I simply expose an endpoint that validators can hit, we get the validator, we create a transaction, we send it to the Solana blockchain, however that happens. It's very simple, RPC call that you have to do over here. And then we decrement their balance. Can you guess what problem is going to happen, and why is this extremely vulnerable to have an endpoint like this? The answer is the validator can just bombard this endpoint. They'll send 1,000 requests immediately at the same time to this endpoint. What will happen then? All 1,000 requests will come and get sort of stuck over here, or wait for the callback queue to be cleared for this. All of them will have the validate at this point. Multiple parallel requests will reach line 93 with the validator having some pending balance, $2, $5, 3 sol, 0.1 sol. And you'll end up paying parallelly for those 1,000 requests. So rather than paying them 3 sol, you'll pay them 3 sol multiple times. Have you tried this ever on Google Pay? If you only have 100 rupees left, you quickly take 2 phones and send 100 rupees at the same time to 2 different friends and hope your 100 rupees goes to both the users and your balance just becomes 0 because you're sending it at the same time. Same thing. Validator can hit this endpoint. If the validator hits this endpoint together multiple times at the same time, then this transaction will be forwarded to the Solana blockchain multiple times with their pending payout, which is, let's say, 3 sol. So we'll send them 3 sol multiple times, and then we'll set pending payout to 0, but it doesn't matter anymore. We have sent them 100 sol when we were supposed to send them 3 sol. So you get the idea. This endpoint, even though I've introduced it and it sort of works, of course it doesn't work right now. I have to introduce Solana/web3.js. So I have to do one add Solana/web3.js. I have to import a few things from Solana/web3.js, the system program and the transaction, and also connection. And then I have to create a new connection to an RPC. Let's say the RPC is just the Solana mainnet. And then I have to forward this transaction. Const serialized transaction is this thing. That works. I think there's an easier way to do it as well. Connection and transaction. We have to introduce a public key over here, a private key over here. This backend will eventually have, the private key of ours, the platforms, better uptime. We are the ones who are paying people. We're also accepting payments from our users. We're also sending them back to our validators. So you'll need to add a private key over here so that the validator signs this transaction and sends the message to everyone. So this part is very simple. Adding a transaction that is sending Solana to someone, but this is not right. This endpoint, even though it feels very simple and everything seems right here, there is a problem here, and this problem exists in any system that does financial transactions, a Paytm or a Google Pay, or even a bank. Okay, when you're sending someone a transaction, you need to ensure this transaction that's going to the Solana blockchain and this database update, they are both happening together. And while they are happening, I do not allow another transaction from the user. I need to make sure that a single request from a user is getting processed at a time. If a user sends me 10 requests, that's fine. They can ask for 10 withdrawals of 3 SOL. But I will first make sure their first transaction goes through. Only then will I start their second transaction. We need to make sure their requests are getting handled sequentially. So, that is where you have to add some logic here. Either shove all of these transactions to a queue and slowly process the queue to make sure everything happens sequentially. This is exactly what's called a distributed transaction. We understand transactions. We saw them a while back. What is a database transaction? We saw it here. Okay. In the hub, whenever we were doing website text.create, we were updating the user's payout. We were doing both of these together in a transaction. What does a transaction mean? If this fails for whatever reason, this fails as well. We want something similar. We want to make sure that the API may the Solana transaction succeeds, then this should also succeed. In case this fails for whatever reason, which it can, the blockchains are highly unreliable, slow sometimes, might take 30 seconds for the transaction to succeed. This decrement shouldn't happen until this has succeeded. And if this has failed, then this should fail as well. If this has failed, then this should be retried, should not be retried, or you can't really revert this. Like if this fails, then you need to just retry this again and again and update the database. You can't really ask the blockchain to send you money back. After the money is gone, it's gone. But for some reason, if this succeeds and this fails, you need to keep retrying this to update the pending balance to be 0. So this should also happen in a transaction, but unfortunately, can you do transaction between two different systems? You sort of can. There are ways of doing it. That's exactly what's called a distributed transaction. You want to make sure this happens in a different system, the Solana blockchain, and this happens in a different system, the Postgres database, together, or neither one of them happens. So these are the two challenges here: sequentially processing transactions of every user, making sure the Solana blockchain payout and the database decrement of the payout happens at the same time, or happens in a transaction. If one of them succeeds, the other one should succeed. If one of them fails, then both of them should fail. So let me leave this as a to-do here. Let me remove everything I added. There is one endpoint that's currently exposed, but does nothing. It's an empty endpoint right now. How would you build this? How would you build a distributed transaction between Postgres and the Solana blockchain? How would you make sure that a single user isn't able to pull out more Solana that they currently have in the centralized database? That's the assignment for today. With that, we will end it. I will see you guys in the next one. Bye-bye.